Building an FDE organization is about turning technical talent into a team that can find customers, support deals, and communicate product value clearly. The structure matters because the right organization makes field feedback useful instead of noisy. The reporting line decides what the FD function really becomes. It shapes the incentives, the budget, and whether the team learns from deployments or just handles requests. If the team sits in the wrong place, it can drift toward the easiest thing to measure instead of the most valuable thing to build. A strong reporting line also determines who pays for the work and whether the function is treated as a strategic asset or a service desk. An FD role usually has 3 jobs at once: deliver a real enterprise AI application, shape the human workflow around it, and send deployment lessons back to the product team. That only works when the role can change the system technically and still stay independent enough to avoid being managed like a sales quota. FD teams usually live in one of 3 places: engineering, sales, or a standalone function. Where the team sits changes what it gets rewarded for, and that shapes the quality of the work. The reporting line is not just an org chart detail. It changes the day-to-day pressure on the team, so the same FD role can behave very differently depending on where it sits. The layout below compares the 3 reporting patterns side by side. The useful thing to watch is not only who the FD reports to, but what kind of work that structure encourages. Each column pulls the role toward a different center of gravity. Engineering pushes toward systems, sales pushes toward deals, and a standalone function tries to protect the deployment work while still keeping close to product and customers. Engineering is the cleanest home when the FD is really building deployed software with customers. That structure keeps the role anchored in technical quality instead of short-term account pressure. The work can then be defined in technical terms, which matters when the customer problem spans architecture, workflows, and production readiness. That framing helps the team stay focused on whether the system will actually hold up. An FD in engineering needs to think about how the whole application hangs together: model calls, data flow, interfaces, and the places where failures can appear. That includes the handoff between people and the model. A good deployment is often less about raw model quality and more about how the work moves between human judgment and automated steps. The team should use evidence before shipping. Tests, review sets, and observed outcomes tell you whether the system is ready, instead of relying on a polished demo or a gut feeling. And once the system is live, guardrails, permissions, monitoring, and rollback paths become part of the job. Those are the pieces that keep a deployed AI workflow safe and recoverable. In this model, the FD sits between product learning and customer reality. Technical problems can be carried back upstream as product changes, without being filtered through sales urgency. Enterprise deployment usually crosses legal review, identity controls, audit logging, and human approval. The FDE's job is to connect those parts and prove with evidence that the new workflow works better than the old one. Sales is the tempting first home because it keeps the FD close to the customer and close to revenue. The danger is that the role starts inheriting the wrong incentives. That setup can feel simple, but it mixes two very different jobs. Supporting an account is not the same thing as building a sound deployment. Once the reporting line runs through sales, the FD tends to be judged by deal movement, demo success, and renewal safety. Those signals matter to the account team, but they do not tell you whether the system is technically healthy. Quota-driven work and outcome-driven work follow different rules. If the same person is asked to serve both, the pressure can pull the role towards speed and appearances instead of durable value. A quota environment rewards visible activity, meetings, demos, custom promises, and heroics. An outcome environment rewards fewer workarounds, better adoption, and lessons that improve the product for the next customer too. AI makes that risk sharper. A system can look convincing in a sales room and still break when the prompt changes, the data shifts, or the customer adds a human checkpoint. So deal pressure can hide real deployment problems. A standalone FDE team works best when the company is large enough to give it real authority. That structure protects the role from being captured by any single department. The advantage is clarity of purpose. The team exists to connect product, engineering, and implementation, instead of acting as an extension of sales or a sub-team inside engineering. This could be the best match for a complex enterprise AI product because the team can shape both product direction and implementation practice. It also gives leadership a place to define what production-ready means and to keep technical judgment separate from commercial pressure. The trade-off is political ambiguity. If ownership is vague, the team turns into a handoff layer, with no clear authority over roadmap changes, sales disputes, or customer escalations. Role placement changes what the team optimizes for. The three common options here are engineering, sales, or a standalone home, and each one pushes the function toward a different kind of trade-off. Keep this frame in mind while comparing the options. The point is not to pick a title first, but to match reporting structure to the kind of work the role actually does. When the role reports into engineering, the team tends to favor technical quality, product learning, and reliable deployment. Under sales, the focus shifts toward deal support and fast customer response, which can pull work into bespoke commitments. A standalone function works best when the company has repeated enterprise deployments and needs clear ownership plus reusable processes. That rule captures the core judgment. If the role directly affects production behavior, quota pressure can distort priorities, so the reporting line should protect the work from short-term sales incentives. The shift from a promising pilot to a workable deployment depends on where the FDE gets involved. The real difference shows up in ownership, workflow design, and whether the system can survive outside the demo. A deployment usually fails or succeeds because several groups have to coordinate at once. Reporting lines tell us who makes decisions, who carries the risk, and who has to keep the system running. Before an FD steps in, the project often looks encouraging on the surface, but lacks the structure needed for real use. The gaps tend to show up only when people try to move beyond the first happy users. The demo may impress people, but a demo only proves that the model can perform in a controlled moment. It does not prove that the surrounding workflow is ready for daily use. That early workflow often depends on a few motivated people who are willing to absorb the friction. Once the audience widens, the shortcuts and manual steps start to break down. Liking the system is not the same as proving value. Without a concrete metric, nobody can tell whether the deployment is improving speed, quality, cost, or reliability. When ownership is vague, problems bounce around instead of getting solved. The buyer thinks the vendor should handle it, IT thinks the business team owns it, and the vendor waits for a decision. That missing operating plan matters because production systems need routine checks and a path for handling failures. Governance is what keeps the project from becoming an unsupported experiment. A good FD does not just help the model perform better. They reshape the setup so the work can be measured, supported, and expanded without guessing. The first step is focus. A narrow use case makes it easier to define success, remove noise, and build something the customer can actually adopt. The model also has to live inside the customer's systems, permissions, and constraints. That means application architecture matters as much as model quality. Clear role boundaries prevent confusion and unsafe assumptions. Some tasks belong to the model, some require review, and some stay firmly with the human operators. Before the system spreads to more users or more workflows, it needs checkpoints. Those gates stop weak performance from being scaled too early. Production adoption tells you whether people return to the tool when real work is on the line. Demo excitement fades fast. Repeated use is much stronger evidence. This feedback loop is what turns one-off rescue work into product improvement. Every manual workaround and failure mode becomes input for the next version of the system. That final shift is the real test. A clever pilot can impress a room. A repeatable enterprise deployment keeps working across people, systems, and time. Salesforce's Ready in 6 idea points to something practical, getting a customer into a usable state, not just closing a deal. That makes it a good anchor for thinking about work that sits between product design, implementation, and real customer adoption. The phrase captures a role that mixes technical problem solving with business context and communication. The value comes from translating customer needs into a solution that can actually be deployed and used, which is very different from simply presenting a product. That shifts the metric from winning interest to delivering working outcomes. When the real test is whether the customer's process runs correctly, the role takes on engineering ownership. The work has to hold up in practice, not just sound good in a proposal. A field vignette makes the deployment problem concrete. An AI assistant can look good in a demo and still fail in practice. The point is to follow what happens when real users, real edge cases, and real trust enter the picture. Early success often comes from the easy examples that fit the demo script. Once the assistant faces messy support tickets, the question changes from can it respond to can it respond safely and consistently enough to be used. That is where hidden problems show up. If the model invents policy language and humans must rewrite half the drafts, the tool stops saving time and starts creating risk, so adoption falls away. An FD looks at this like an operational system, not just a model. The real questions are about scope, review, evaluation, and monitoring, because those are the levers that turn a promising prototype into something a team can rely on. The boundary has to be precise, or the assistant will be asked to do too much. A narrow task definition reduces ambiguity and makes it possible to measure whether the system is actually doing the right job. Not every ticket belongs in automation. Some requests are routine and safe to draft, while others need a human from the start, so routing becomes part of the design. Review rules protect the highest risk answers. If a reply mentions policy, billing, or exceptions, that draft may need a person to approve it before it reaches the customer. A useful evaluation set should reflect the real mix of normal cases and failure modes. Without that, good enough becomes a guess instead of a standard the team can defend. The system can shift after deployment as policies change or new ticket patterns appear. Monitoring needs to catch those changes early, before the assistant starts producing stale or unsafe answers. The fix is usually a set of controls working together. Limit the workflow, send the right cases to the right path, ground answers in approved policy text, and test for the failures you already expect. That combination lowers the chance that the system surprises the people who depend on it. That is why this work sits closer to product reliability than to sales polish. A useful deployment earns trust by staying accurate, reviewable, and predictable when the real workload arrives. Cost, margin, and scale are the questions that decide whether an FD role is a strategic function or just a support expense. The rest of the section looks at how those choices change ownership, incentives, and the ability to grow the team. Those four questions force an executive to look past the job title and ask who pays for the work, who benefits from it, and whether the structure can survive beyond a few strong individuals. That is the difference between a role that fits the business and one that only looks efficient on paper. Ownership of cost shapes what shows up in the margin, so hiding the role inside sales can make it look cheaper than it really is. Ownership of outcome changes the manager's priorities, and incentive design changes behavior. If quota is attached, the team will push towards short-term revenue events. The last test is scale. A few heroic people can save deals, but a real function has to turn that effort into a repeatable process. That balance is why the standalone model often works best for serious enterprise AI teams. It keeps sales pressure from distorting the role, while still keeping the work close enough to the product that each deployment creates learning the company can use again. The real question here is where ownership stops. A clear boundary keeps an FD team focused on quality and keeps it from turning into a catch-all support group for every customer request. If the team is expected to agree to whatever a customer asks for, it has crossed out of product ownership and into service work. That matters because consulting behavior makes the team reactive instead of selective, and selective judgment is what keeps the function useful. The function should be responsible for how well the product lands in the customer environment, deployment, instrumentation, and workflow design. It can work on improvements that scale across customers, but it should not become the place where every odd request gets parked just because no one wants to push back. A firm boundary keeps the work economically healthy because endless one-off requests eat time and margin. It also protects the team itself, since people stay sharper and more engaged when they're solving meaningful problems instead of absorbing every exception. Reporting lines send a signal to candidates about what kind of work they will actually do and how much technical authority they will have. That signal matters when the role needs people who can build real systems, not just support a pitch. Strong engineers read the structure behind the title. If the role sits in a credible engineering setup, it attracts people who want to ship production software and own technical decisions. If it looks like sales support, many of those candidates will pass. A title can be polished without changing the substance of the job. The reporting line, the team around it, and who owns decisions tell candidates whether the role has real depth or just a nicer label. Once the structure is clear, the hiring question changes. The goal is to find people who can thrive in that environment by combining technical judgment, workflow sense, and customer awareness, rather than relying only on elite credentials. Pedigree can be a weak signal for this role because the job depends less on status and more on judgment under ambiguity. The useful question is which engineer will learn the customer, shape the product, and work independently without getting trapped by prior habits. The real hiring problem is not raw technical strength. It is finding someone who can separate what they have done before from what this customer actually needs, especially when discovery, product thinking, and field work all have to happen together. That conclusion sounds surprising because seniority usually looks safer on paper. In an FDE role, though, a lighter attachment to one fixed method can help someone adapt faster and avoid forcing the wrong pattern onto a messy problem. The contrast becomes clearer when the role is defined by uncertainty. Once the work is about learning, adapting, and finding the real issue, the hiring bar shifts away from credentials and toward flexibility of thought. A forward-deployed engineer sits between the customer and the product, so the work spans several modes at once. The important skill is speed of understanding, reading how the customer actually operates, then uncovering the problem behind the first description they give. Deep experience is valuable when a task repeats, but ambiguity changes the game. The engineer has to recognize when a familiar solution does not fit and resist the urge to apply it anyway. That ability to question the template is what keeps the work on track. Pedigree can stop being a useful shortcut when the role rewards judgment, curiosity, and adaptability more than polished credentials. The point here is to separate impressive background from actual fit for open-ended deployment work. A strong school, a famous company, or deep specialty can correlate with quality, but those signals can also bias how someone approaches a customer problem. In forward-deployed work, the danger is that the candidate looks credible on paper while missing the messy reality of the customer's process. A person who has spent years in one environment often carries a ready-made model of how things should work. That model can be useful, but it can also shut down discovery before the real constraints are understood. Premature certainty means the answer appears settled too early. Instead of asking how this customer actually operates, the person starts from assumptions and then tries to confirm them. Tool-first thinking puts the stack ahead of the problem. The better move is to start with the workflow and the outcome, then choose the technical shape that fits those constraints. Dependency behavior shows up when someone waits for another team to define the path forward. If their last job came with a fixed playbook, they may struggle when the environment requires them to create the playbook themselves. Early career hires often bring less status-driven certainty and more willingness to ask basic questions. That can be an advantage when the work rewards learning fast, admitting gaps, and staying open to what the customer actually needs. When the real job is finding the problem before solving it, a memorized consulting framework is not the main asset. The stronger trait is the habit of staying close to the customer, the constraints, and the concrete outcome. Public job postings for these roles often emphasize ambiguity tolerance, cross-functional communication, and turning customer needs into working systems. That pattern tells founders something important. The role is built to reward judgment in an open field, so prestige markers matter less than whether the candidate can think and act without a script. Palantir gives a strong example of a hiring model that treats junior-heavy teams as an advantage. The important idea is that some roles reward fast learning and adaptability more than years of repeating the same narrow work. That pattern points to a deliberate staffing choice. The role seems built for people who can ramp up quickly inside a structured environment and take real ownership early, rather than waiting for someone who already knows every edge case. That framing matters because it changes what good hiring looks like. If the job is meant to build judgment, then the team needs people who are teachable, responsive to feedback, and able to make solid decisions under pressure. A long resume does not guarantee fit. For this kind of work, someone with a polished but narrow playbook can struggle when the customer workflow shifts, while someone who can absorb context and adjust the deployment may create much better results. To make that idea concrete, compare the deployment before an FD arrives and after the team starts shaping the system around real use. The contrast shows why the role is judged by learning and judgment, not just by prior pedigree. The useful question is what breaks before the engineer gets involved, and what improves once the engineer starts working inside the customer's actual process. That comparison makes the role visible in terms of workflow, adoption, and feedback into the product team. Before involvement, the problem is usually a mismatch between the model and the real workflow. After involvement, the engineer turns that rough setup into something measurable and usable, and the results feed back into product decisions about what should be built next. That is why the hiring signal should focus on how quickly someone learns and how well they make decisions in messy situations. A polished resume can help, but it is a weaker signal than the ability to adapt, diagnose, and improve the system in the field. Labor market sizing gets complicated as soon as job titles start splitting into multiple labels for the same kind of work. The point here is to measure demand without being fooled by naming conventions. A search by one exact phrase misses roles that do the same work under different names. If the title is fragmented, the count will look smaller than the actual market. Companies often describe the same field-embedded deployment work in slightly different ways. That means the analyst has to group roles by function, not just by wording. That title is the most direct label, but it is only one way the market expresses the role. A literal match captures part of the picture, not all of it. Some firms use an AI-flavored title even when the work is still customer-facing deployment. The label changes, but the operating pattern can stay the same. Architect titles often signal design responsibility, but in practice they can still sit inside the same deployment motion. The name alone does not tell you whether the role is truly field-based. This kind of title often points to someone shaping how a product lands with a customer. The work can be close to engineering, even when the title sounds more advisory. Some companies preserve the forward-deployed idea, but wrap it in a software engineering title. That is another sign that title search alone will miss real roles. New labels appear as the market changes, especially around agentic systems. A fresh title can still describe the same customer-embedded deployment function. If you count only one label, the market looks too small. It also becomes harder to recruit because comparable candidates may sit under different compensation bands and reporting structures. The practical move is to begin with a precise search and then widen it carefully. That keeps the count disciplined while still recovering roles that belong in the same category. The first pass finds exact matches, then the next pass pulls in close equivalents. After that, the job is to filter out roles that only support implementation and to separate them from roles with actual engineering ownership. No counting method is perfect because titles keep changing. Even so, a structured method is far better than assuming the exact words in the posting define the entire market. A simple example makes the logic concrete. Once the titles are grouped by function, the size of the market changes immediately. Imagine a board with exact matches, adjacent matches, and roles that only look adjacent on the surface. That split is what turns a raw search into a real estimate. Those are the easy ones to count, because the title matches the search directly. The problem is that this group is only the visible core of the market. These are the roles that matter just as much, even though the wording is different. They extend the market beyond the literal search term. These need review because they are not all true field roles. Some will belong outside the count once you separate deployment work from sales support. The difference is the lesson. A literal count gives 12, but grouping the adjacent titles brings the total to at least 21 relevant roles, with another 6 that need judgment before you include them. The exact number will move from week to week, so the method has to be stable even when the postings change. The real goal is to see the structure of demand without getting trapped by naming conventions. Once the count is clear, compensation becomes the next filter. Base pay and total compensation tell different stories about what the role is really worth to the company. Base pay is only the fixed salary. Total compensation is broader, because it includes the cash salary plus the extra value coming from bonus, equity, signing grants, relocation, and other benefits. Two postings can look similar on the surface and still offer very different packages. A higher base with little equity is not the same as a lower base with a richer long-term package and more strategic scope. That distinction creates predictable mistakes in hiring. People focus on the visible salary number and miss the rest of the offer. A candidate may anchor on the largest salary figure and assume it means the stronger role. That reaction is natural, but it ignores the rest of the package. A manager can also misread the market by comparing only base pay. A lower salary can still be competitive once equity, bonus, and scope are included. The real decision usually comes from the whole offer, not a single number. That is why compensation has to be read as a package, not as a headline. Compensation belongs inside labor market sizing because it tells you something about the job itself. A richer package can signal more ownership, more customer responsibility, or a stronger push to keep the person long-term. The right question combines quantity with meaning. If you ignore the difference between base pay and total compensation, you will misread both the market size and the incentives facing candidates. Specialization can help in many engineering jobs, but in an FDE role, it can also narrow how people interpret problems. The important issue is whether the engineer can question the first request and think from the customer's real workflow, not just from a familiar technical pattern. A highly specialized hire often learns to trust a known system first. That works well when the work is stable, but customer problems are often messy, and the engineer has to reason beyond the default technical answer. The first request from a customer is often a symptom, not the root cause. Before building anything, the engineer has to ask what failure is really happening in the process. A dashboard sounds like the obvious fix, but if the data underneath is untrusted, the dashboard just presents confusion more cleanly. The real work may be cleaning the pipeline or fixing ownership of the source data. Automation is not useful if the process is missing a human decision in the right place. Sometimes the fix is not less human work, but the right human check at the right moment. A faster model only matters if the model is the bottleneck. If the workflow breaks before inference, then improving the model does almost nothing for the customer. That habit of pushing past the first answer is a form of disciplined independence. It means investigating the system, reframing the problem, and sometimes telling the customer that their preferred fix is not the best one. Mission-type tactics fit this work well because the goal is clear, but the route is not. The manager defines the outcome, and the engineer chooses the method that actually solves the customer problem and leaves something reusable behind. That freedom only helps if the engineer is willing to make judgment calls without a script. A person who waits for a playbook tends to copy patterns instead of thinking through the customer situation. The hiring logic makes sense when you trace it back to the early FDE model. It was shaped by the kind of work the role had to do, not by abstract hiring theory. That matters because the role was built first and the hiring philosophy came later. When a role grows out of real operational needs, the traits that get valued are usually the ones that solve those needs reliably. The original model lived in settings where the product could not be handed over as a standard package. Someone had to carry the work into the customer environment, adjust it to local reality, and then bring the learning back so the core product improved for everyone. That is why discovery is so important. A strong FDE listens carefully, checks whether the stated problem is really the problem, and then turns that understanding into a technical and operational change the team can actually ship. A person can be very good at executing a known pattern and still miss the real issue. When the pattern does not fit, the better skill is to question assumptions, find the actual constraint, and steer the conversation toward that constraint instead of forcing the wrong solution. Cost, ownership, and scale are the questions that matter once the hiring plan reaches the executive level. The real issue is whether the team creates durable product leverage or quietly turns into an expensive support layer. Hiring philosophy always shows up in the margin. The kind of people you bring in shapes the kind of work the team becomes, and that has a direct effect on how efficient the function can be. If the team is filled with people who expect heavy structure and consulting-style process, the function drifts toward custom service work. That produces polish for individual customers, but does not build reusable learning that strengthens adoption or feeds the roadmap. Reporting lines decide what the team optimizes for. Too far from product, and every solution becomes one-off work. Too far from go-to-market, and the group becomes isolated from real customer use. The right position keeps field autonomy while still pushing useful feedback back in a product. Compensation sends a message about ownership. Equity points people toward long-term learning and long-term value, while a purely cash-heavy offer tends to attract candidates who want certainty now, not necessarily leverage that compounds inside the product. The hardest test is whether the function can scale beyond a few exceptional people. If success depends on rare senior operators, you have built a boutique consulting layer, not a lasting capability. A mix of junior, high-curiosity hires can work well when the team gives them clear mission-level tactics and tight feedback loops. Hiring for an FDE team comes down to one practical test. Can the person work inside uncertainty and turn what they learn into product value? That matters because the role is not just technical support. It sits between the customer's environment and the product team. A strong resume is not enough here. The better candidate can walk into a messy customer setup, identify the real constraint, adjust the deployment, and bring back something the product team can reuse. Sometimes the more specialized candidate is less useful in this role because they protect an old approach instead of testing the situation in front of them. Lower specialization can actually help when the job demands curiosity and fresh diagnosis. That hiring rule leads directly to team design. Give the field enough freedom to solve real problems, but keep that freedom tied to a structure that prevents every customer from becoming a one-off product. The hiring question here is simple. What actually separates a strong forward-deployed engineer from a polished generalist? These 5 traits give you a practical way to spot someone who can handle real deployments and turn fieldwork into product learning. The risk is not just missing a quota target. A weak hire can slowly pull the company toward one-off customer work, while the right person turns a hard deployment into something the whole product team can reuse. That question gets closer to the real job. Architecture skill matters, but the better signal is whether the person can help a customer actually adopt the product and bring useful lessons back to the team. Before scoring candidates, the role has to be described in plain language. Once the job is clear, it becomes much easier to tell whether someone is merely technically fluent or genuinely able to work in the field. A lot of the confusion comes from vocabulary. These phrases sound familiar, but each one points to a different part of the work, so it helps to name them carefully. Enterprise deployment is not a demo. It means security reviews, data rules, approval chains, and existing tools that all have to be respected before the software can really live inside the organization. For an AI product, architecture includes model calls, retrieval, guardrails, logging, human review, and the workflows around them. The important part is that the system is not just a model. It is the full structure around the model. Workflow design is about dividing labor cleanly. Some steps belong to the machine, some belong to a person, and the best deployments make that boundary explicit instead of leaving it vague. Eval-driven deployment keeps the work honest. Instead of shipping by instinct, you define quality checks that show whether the system is actually getting better or just producing more output. When agents can take actions on behalf of users, reliability and governance become central. The question is whether the system behaves safely, predictably, and inside the rules every time it is allowed to act. That intersection is what makes the role hard to define and hard to fill. Titles change from company to company, but the core question stays the same. Can this person make the technology work in the field and make the product smarter because of it? Those role requirements lead to 5 traits that matter most in hiring. The goal is not to find a perfect personality profile. It is to look for evidence that the person can do the real work. That is why the panel card should stay short. Hiring works better when you score observable evidence rather than trying to read a candidate's character from a polished conversation. Each of these lines is a clue about what to listen for. The strongest answers sound specific, grounded in action, and tied to a real change in the customer environment rather than a vague description of effort. A rubric only helps if it filters out the wrong fit. Very smart people can still be wrong for this role if they need perfect requirements, freeze without approval, or treat customers like passive recipients of expertise. Independent thinking is the first trait because the FDE cannot wait for someone else to diagnose the problem. The role demands someone who can find the actual issue, not just the easiest story to tell in a meeting. That means looking past the surface explanation. In field work, the first complaint is often only a clue, and the real problem may be hidden in workflow, incentives, timing, or data shape. Strong role descriptions point in this direction. The work is active diagnosis. Understand the customer environment, identify what is really failing, and shape the solution from that evidence. A good interview question forces that kind of investigation. If the candidate went straight to a generic fix, that usually means they did not really understand the system around the model. Field work is full of false diagnoses. A customer may ask for a better model when the true issue is that the result reaches the wrong person at the wrong time in the wrong format. A useful example is a support team asking for a chatbot when the real bottleneck is trust. If the agent needs case history and citations, the right move is to redesign the workflow around evidence, not spend weeks polishing conversation style. The second trait is outcome orientation. A strong FD thinks in change behavior and measurable results, not in how many features or tasks were completed. That shift matters because shipping something is not the same as improving the business. The role is about adoption, resolution time, throughput, conversion, or another concrete result that shows the work mattered. Technically strong people often stop at the build. In this role, that is not enough. The candidate should be able to name the before state and the after state with real clarity. Role postings that emphasize customer impact are useful here because they frame the work around use, not abstraction. The question becomes whether the engineer can get a deployed system into practice and make it matter. That interview prompt makes the candidate connect engineering work to adoption and measurement. It also reveals whether they have ever worked in a loop where field experience feeds the product team back upstream. That feedback loop is the real value of good deployment work. Without it, the team just accumulates one-off customizations instead of building a stronger product. The third trait is comfort with ambiguity. This does not mean liking chaos. It means you can make progress before the problem is fully specified. That matters because field work rarely arrives with a clean definition. The candidate has to be able to move while the shape of the problem is still becoming visible. Enterprise AI almost always starts messy. The use case may be unclear, the data may be dirty, the human workflow may be the real product, and the model may fail differently across teams. That is why the panel should look for evidence that the candidate can act before every answer is known. The best people turn uncertainty into a sequence of small, testable steps. A strong answer usually sounds like a process. Instead of waiting for perfect clarity, the person forms a hypothesis, tests it, measures the result, and then updates the approach. This trait also prevents overbuilding. People who are comfortable with ambiguity are less likely to promise a giant custom solution too early, and that keeps the company from scaling heroics instead of learning. The fourth trait is genuine customer charisma. That is not sales polish. It is the ability to build trust, keep momentum, and translate technical limits in a language the customer can use. The key is credibility. The engineer has to make the customer feel understood while still keeping the work moving forward. That means the FD can sit with a skeptical operator, explain the behavior clearly, and still leave the person more confident than before. The truth can be blunt as long as it is delivered in a way that helps the customer act. Role framing from customer-facing deployments points to the same requirement. The work depends on trust, so technical fluency alone is not enough. The person has to be believable in the room with the customer. That matters because customers are risking time, reputation, and internal process changes. Even a decent technical answer can fail if the FD cannot help the customer feel safe moving ahead. A good listening test is whether the person can lower the temperature in a tense conversation without losing direction. That is the kind of presence that moves a real customer relationship toward action. The fifth trait is builder instinct. This is the difference between talking about the system and actually shipping it into something robust enough for daily use. Plenty of candidates can describe the architecture, The stronger signal is whether they instinctively move towards something that works in practice. That practical instinct shows up in the details, building the thing, adding instrumentation, testing it, and simplifying it when the environment is messy. The role rewards people who know how to make software reliable under constraints, not just elegant on paper. Research on FD roles points to the same distinction. The job is not only about architectural thinking. It also requires hands-on iteration that turns a design into a working deployment. Builder instinct often shows up in small but important moves. The examples are practical, and each one changes how the system behaves in the field. Removing a manual handoff is a sign that the person saw friction where others saw process. Small reductions like that often make the whole deployment easier to use. Adding logging shows that the person thinks about supportability, not just launch day. When failures happen, the team needs enough visibility to understand and fix them quickly. A simple evaluation set is often enough to make progress measurable. It turns vague claims about quality into something the team can actually inspect over time. Good builders also know where human review matters most. They do not add friction everywhere. They put people in the loop where the risk is highest and leave the low-risk path simple. Turning a prototype into maintainable software is often the hardest step. That is where builder instinct shows up most clearly, because the work has to survive real use, not just a demo. That is the real divide. Smart people can describe a system, but effective builders change the system so it works better for the customer and the team. A concrete deployment example helps make the traits visible. The point is to see how field behavior changes when the role is focused on getting to a useful result quickly. That framing matters because it makes the role tangible. The success condition is not abstract capability. It is a customer reaching a usable outcome with enough structure to repeat the process. Before the FD steps in, the problem may be organizational rather than technical. The customer is often stuck deciding what to automate, who should see the output, and how to define a good result. The right response is disciplined, not expansive. Start with one valuable use case. Make the success condition measurable, and build the smallest version that can survive real usage. After that work, the outcome should be visible in more than one place. You want to see adoption change, the system change, and the team's understanding change. Those three signals tell you the deployment mattered. People are using it differently. The engineer actually changed the workflow, and the product team now has something they can carry forward. That is the hiring lens in plain terms. Strategy talk is not enough unless it comes with evidence of real field judgment and real hands-on work. This rubric is also an operating model question. Where you place the role, how you budget it, and how you measure it will shape whether it creates reusable product learning or drifts into custom services. Executives should treat the role design as structural, not cosmetic. The reporting line and the incentives determine what kind of work the team will actually do. If the role rewards product learning, it belongs close to product and engineering. If it is managed only for utilization, it can drift into low-margin custom work that looks busy but does not compound. Title fragmentation makes sourcing harder because the same job can appear under many names. The safer approach is to compare responsibilities, not labels, and then read the labor market against the work itself. Compensation also needs a careful read. Base pay and total compensation are not the same thing, and a leadership team can under-budget badly if it looks only at salary instead of the full package. The main mistake this rubric is designed to prevent is hiring a polished presenter instead of a real field engineer. That kind of candidate can sound excellent and still fail when the work becomes messy and ambiguous. A technically impressive candidate can still be the wrong hire if they are really a pre-sales architect in disguise. The issue is not intelligence. It is whether they can discover the real customer problem and carry the deployment through uncertainty. That is why the five traits belong together. You want someone who can think clearly, stay tied to results, work through uncertainty, build trust with customers, and actually ship the solution. A simple interview sheet can make that judgment much easier. Each question should force the candidate to show evidence from a real deployment rather than offer generic claims. Start with the problem itself. Good candidates can separate the symptom from the underlying issue and explain what was actually blocking progress. Then ask for the change. If the person cannot describe a before and after shift, it is hard to tell whether their work mattered. That question surfaces ambiguity. Strong FDs can explain how they moved when the problem was still fuzzy instead of waiting for perfect instructions. Trust matters because the role is customer-facing. The answers should show credibility, good judgment, and the ability to keep the relationship moving without overselling. That question gets at builder instinct. You want evidence that the person did hands-on work, not only strategy or coordination. The final question closes the loop. Good field work should leave behind reusable product learning, not just a completed engagement. If the candidate answers all of those well, the role may fit. If they only handle the architecture question, you may have found a good presenter rather than a good FD. The practical rule to carry forward is to score for field judgment, not for theater. That standard keeps the hiring process focused on people who can work in real customer conditions and leave the product better than they found it. Designing the interview loop means deciding what each interview is meant to measure, who should ask what, and how to compare candidates fairly. The structure matters because a weak loop produces noisy hiring decisions even when the interviewers are experienced. These two cases show what a strong FDE interview really tests. Not quick answers, but how a candidate frames an ambiguous business problem. The goal is to see whether they can find a real constraint before they start proposing solutions. Start with two different hiring loops because the contrast makes the point clearer. In both cases, the interviewer is not looking for a memorized answer. They're looking for the candidate's reasoning under uncertainty. In the emergency dispatch case, a weak candidate grabs the first obvious fix, but that usually means they have not understood the system. A strong candidate separates the workflow into pieces, asks what data exists, and defines what faster actually means before suggesting any change. The logistics scenario adds autonomy, which makes the judgment even more visible. A good candidate first asks what the system can touch safely, which decisions can be reversed, and where human escalation is required, because those are the boundaries that determine whether an agent belongs at all. That is why these cases matter. They are not puzzles for their own sake. They stand in for the real work of turning messy customer problems into a deployable system. A forward-deployed engineer has to decompose the problem, choose the right technical shape, and drive adoption in the customer environment. The interview loop should therefore test judgment under uncertainty, because that is the skill that decides whether the deployment succeeds. This part is about what a strong FDE interview loop really measures, whether someone can find the real customer problem, design something that fits actual use, and turn one engagement into reusable product learning. The loop has to probe more than presentation skills. It should reveal whether the candidate can diagnose need, shape a workable deployment, and leave the company with something it can use again. Those three questions separate surface polish from real field judgment. A candidate may talk well in a mock scenario, but the stronger signal is whether they can identify the actual pain, make the solution fit the customer's workflow, and capture what should carry into the next deal. That third question reaches into architecture and strategy at the same time. The best FDEs know the model is only one part of the system. Prompts, tools, data access, permissions, and the interface all shape whether the customer gets a useful workflow or just a clever demo. A good loop should make those strengths visible instead of assuming them. The candidate needs to show technical depth, but also the ability to work across teams and carry responsibility in a real company setting. At the architectural level, the candidate should be able to break the system into retrieval, orchestration, guardrails, and the user-facing workflow, then explain how those parts fit together. Deployment should be grounded in tests and measurement, not intuition alone. Strong candidates talk about success criteria, concrete test cases, and how they would compare behavior before and after a change. Agent design needs clear boundaries. A solid candidate knows when the agent should act on its own, when it should ask for confirmation, and when it should stop rather than continue blindly. The question is not only whether the model can do the task, but whether people will trust the process around it. Good workflow design puts the model in the right step with the right level of control so humans can stay confident in the result. The candidate also has to operate across product, sales, customer success, and sometimes legal or security. That means knowing who owns what, where decisions belong, and how to avoid confusion as the deployment moves through the company. A loop like this should separate someone who can give a polished demo from someone who can actually carry a deployment. The difference shows up when the work gets messy and the candidate still has a way to keep the project moving. If those signals are absent, the interview process tends to reward confidence over competence. That usually produces people who sound strong in the room, but struggle once the customer, the workflow, and the constraints all become real. Strong interviews for this role usually test three different things: fit, technical depth, and judgment under ambiguity. The structure matters because each part reveals a different failure mode, and together they show whether someone can work with customers and still make sound technical choices. A clean interview loop separates social judgment from technical reasoning and from problem framing. That keeps you from overvaluing polished answers in one area while missing weaknesses in the others. The first pass should probe how the candidate operates with people, pressure, and incomplete information. For an FD, that means looking for evidence of real customer interaction, not just generic teamwork language. A vague culture chat will miss the point. You want to hear how someone handles changing requirements, unclear ownership, and moments where the customer needs help, but the answer is not obvious. The best questions force the candidate to surface real decisions, not polished slogans. They should describe trade-offs, pushback, and how the work changed after contact with a customer. A good answer will show that the first version was only a starting point. The customer conversation should have revealed a constraint, a mismatch, or a better priority that changed the deployment shape. That question checks whether the candidate can separate symptoms from root cause. Strong people can explain what data, feedback, or behavior told them where the real issue actually was. Pushback matters because the best answer is not always the fastest yes. You want someone who can say no or not yet without damaging trust, and who can explain the reason clearly. That situation tests coordination. The candidate needs to show how they balanced competing goals, clarified the decision owner, and kept everyone aligned enough to move forward. That is a very FD-specific skill. Progress has to come from careful commitments, small wins, and honest scope control, not from saying yes to everything in order to sound helpful. The real test is whether the candidate can keep momentum without creating false expectations. Motion alone can hide weak judgment, and in customer work, that mistake becomes expensive quickly. The second part checks depth, but it should stay anchored in real work. The goal is to see whether the candidate understands systems well enough to explain design choices in context. Trivia questions reward memorization, not engineering judgment. A better interview asks for reasoning about an actual deployment or a believable scenario, so the candidate has to think, not recite. Pick one concrete example and make the candidate unpack it end to end. That gives you a way to see how they think about architecture, data, evaluation, and the constraints around the system. Architecture tells you how the pieces fit together and where responsibility lives. A strong candidate can explain the design choice, not just name the components. Data dependencies expose fragility. You want to know what inputs the system relies on, where those inputs come from, and what breaks when they are missing or delayed. The eval plan shows whether the team measured the right thing before rollout. Good candidates can describe how they checked quality, not just how they built the feature. Failure modes reveal maturity. Someone who has shipped real systems can usually name the likely ways the solution will misbehave and how they would catch that early. These boundaries matter because a solution can be technically sound and still be unusable or unsafe in the customer environment. A good FD thinks about access and control from the start. Adoption metric tells you whether the deployment mattered to users. The best candidates pick a measure that reflects real usage, not a vanity number that only looks good on a slide. A deployment is not finished when it ships. You need to hear how feedback comes back from users, how it shapes the next iteration, and whether the team can learn from what happened in the field. The strongest answers tie the system design to the customer's actual operating reality. If someone can explain the code, but not the workflow, they may know the technology and still miss the job. The final part is the signature round, because it shows how the candidate approaches ambiguity before any solution is chosen. What matters most here is the quality of the framing. A strong case study is open-ended enough to require judgment, and long enough to reveal whether the candidate slows down before acting. That pause is often the difference between a thoughtful deployment and a rushed one. People often rush because they won't look decisive. In practice, that habit can lock in the wrong assumptions early and produce a system that fails as soon as reality shifts. The interviewer should care less about the first idea and more about the questions that come before it. Those questions show whether the candidate knows how to define the problem before solving it. A solid response usually follows a simple sequence. Each step narrows the problem while keeping the real-world constraints visible. First, the candidate should pin down who the user is and what success means. Then they should map the workflow, divide machine responsibility from human responsibility, choose measures and guardrails, and end with a small first deployment instead of an imaginary end state. That progression reveals judgment because it forces trade-offs into the open. Someone who can reason this way is much more likely to ship something useful, safe, and adaptable. This case shows how to think past the obvious AI answer and into the real workflow. The goal is not to name a model first. It is to find the part of the system where delay, risk, and data line up well enough for a useful solution. The prompt is intentionally realistic. Emergency calls come in, people classify them, and units get dispatched under time pressure. That makes it a good test of whether someone can reason about operations, not just machine learning terms. The important part is the system goal, faster response time. Once that is stated, the right move is to ask where time is being lost and who is responsible for each decision, because different bottlenecks call for very different tools. A weak answer jumps straight to a classifier or chatbot. A stronger answer breaks the service into steps first, because the best AI intervention depends on whether the problem is triage, routing, or something else entirely. The best responses sound structured and practical. They show that the person can reason from operations outward instead of trying to force one generic model onto everything. The key move is to trace the process from intake to review, then isolate the delay before choosing a solution. If triage is the bottleneck, AI may help summarize or classify calls. If dispatch is the bottleneck, AI may assist with candidate units, but final approval can still stay with a person. That distinction matters because it separates people who can name tools from people who can choose a safe and useful intervention. In a high-stakes setting, good judgment is part of the technical skill. A strong response asks for evidence, separates prediction from action, and plans a pilot that can be measured. The details below show what that looks like in practice. Before proposing any tool, you need a baseline. Without current response time data, there is no way to tell whether an AI change helps, hurts, or only changes the appearance of progress. A model can suggest the nearest unit, but that does not mean it should send it. In operational systems, the difference between recommendation and action is where safety and responsibility live. These constraints shape whether the system can actually work. Geography affects routing, staffing affects availability, overrides affect trust, edge cases expose failure modes, and auditability matters when every decision may need to be explained later. A pilot keeps the risk contained while the team learns what the model is good at. Keeping a human in the loop lets the system support dispatch without handing over control too early. Good measurement covers both operational and human outcomes. Speed matters, but so do false suggestions, how often dispatchers override the system, and whether the staff actually trusted enough to use it consistently. A weak answer sounds polished but stays detached from the real work. It talks about AI in general terms and skips the hard questions that determine whether the idea is usable. That kind of answer focuses on presentation instead of process. In a case like this, a demo is not enough unless it reflects how dispatch actually operates under pressure. Ignoring those issues is a serious gap because emergency response is not a low-stakes workflow. Any recommendation has to fit rules, accountability, and failure handling from the start. That assumption is dangerous in this setting. Final decisions may need human judgment, especially when the cost of a wrong action is so high. Even a technically correct system can fail if the people using it do not trust it. Adoption is part of the product, and operational trust often determines whether the tool has any real impact. That is why the case belongs in an interview loop. It reveals whether someone can move from abstract AI ideas to a solution that fits a consequential environment, with evidence, constraints, and responsibility built in. This example tests whether the system design accounts for real operational risk, not just model capability. The point is to separate a flashy agent from one that can safely act inside a supply chain. The setup is updated to match a more modern agentic workflow. That matters because the design now has to cover monitoring, decision-making, and controlled execution, not just prediction. The core requirement is continuous sensing plus action. Weather, inventory, and port congestion all affect whether a route is still the best choice. So the system has to combine live signals with business priorities like fewer delays and fewer stockouts. A tool-enabled agent can still be badly designed if its boundaries are vague. The hard part is deciding what it may change on its own, what must be reviewed, and how to recover when a change causes trouble. A strong answer starts with system structure before implementation details. It treats the agent as part of an operating process, which means the candidate has to think about control, accountability, and failure handling. First, the agent needs a narrow action space: suggest, hold, notify, or execute. Then the data inputs have to be explicit, from shipment status and weather to warehouse inventory and carrier limits. The safest design separates low-risk reroutes from high-risk ones and keeps a rollback path plus logs, so every automated decision can be traced. That framing shows the candidate understands that an agent is a managed system, not a free-roaming model. Reliability comes from constraints, and governance comes from visibility into what the system did and why. The rollout matters just as much as the design. Safe adoption usually starts with human visible recommendations, then earns more autonomy only after the system proves it behaves well. At first, the agent only proposes reroutes. That lets the team see whether the logic matches expert judgment before any real shipment is changed. The comparison step gives you a baseline. If the agent and the planners consistently disagree, you learn where the model is weak and where the business rules need to be sharpened. Autonomy should begin where the downside is smallest. Low-risk lanes are a good place to test whether the system can act quickly without creating expensive mistakes. Those metrics tell you whether the agent is earning trust. High override rates can mean the model is unreliable, while avoided delays show whether the automation is actually helping operations. The final gate is consistency. If the agent stays within expected behavior across changing conditions, then broader deployment becomes defensible. The shift is from an ad hoc ambition to an operational system. Once the process is constrained and measurable, product teams can reuse the escalation rules and the feedback loop instead of starting from scratch. The value is not just building an agent. It is making the agent safe to run, easy to monitor, and useful enough to scale. That combination is what turns a prototype into a dependable part of the business. A good interview loop gives each round a clear job, so you can measure different skills without overlap. The goal is a process that feels structured and fair, with each conversation testing one dimension of the candidate. When one round tries to test everything, the signal gets muddy. A focused round makes it much easier to tell whether a candidate has the right judgment, the right depth, or the right way of thinking. Each round has a different purpose. Behavioral fit tells you about empathy and ownership. The technical deep dive checks whether the candidate can explain systems and measurement. The decomposition case shows how they handle ambiguity, and the cross-functional scenario reveals how they work with product, sales, and customers. A compact loop is easier to trust because it stays focused on evidence instead of performance. That discipline makes the interview stronger because every round earns its place and every signal has a clear meaning. Real hiring signal shows up when a candidate thinks beyond surface answers and starts asking the questions that reveal product judgment, execution maturity, and customer empathy. This part focuses on the patterns that separate someone who can handle real FDE work from someone who only sounds technical. Across the interviews, the strongest candidates keep returning to the same habits of thought. They frame the customer problem clearly, separate different layers of the system, and think about how the work will actually land in the organization. That question shows they are not jumping straight to features or model output. They're trying to understand the real business need, because the wrong problem statement leads to a polished solution that still misses the mark. This is a useful distinction in interviews. A candidate who can split the workflow from the model knows that a good system is more than a strong model. It also needs routing, handoffs, guardrails, and a process that fits the user. Strong people do not treat evaluation as an afterthought. They want to know what success looks like, what will be measured, and how the team will tell whether the system is helping or just sounding impressive. Negative constraints matter because they expose judgment. If someone can name the failure modes, the safety boundaries, and the cases the system must avoid, they're already thinking like an owner rather than a demo builder. That kind of instinct matters in real deployments. A good FD knows when the problem has crossed into product decisions, security concerns, or domain expertise that cannot be guessed from the prompt alone. Adoption is where many interviews become revealing. A candidate who can talk about rollout, user behavior, training, and change management understands that a system only matters if people actually use it. That is why the post-launch questions matter so much. If ownership is unclear, support disappears, or every deployment depends on one heroic person, the work does not become durable, even if the technical demo looked good. From the executive side, this is also about margin and scale. People who only handle bespoke customer fixes turn the function into a consulting arm, while people who create reusable patterns and teach others help the product compound over time. That is why reporting line, ownership, and incentives need to support reuse. This part is about the one interview rule that matters most. Judge whether someone can define the real problem, narrow it safely, and leave behind a system the company can keep using. A strong FDE interview looks past cleverness. The useful signal is whether the candidate can frame the customer's need correctly, reduce it without breaking the use case, and build something that survives after the first demo. That same standard should include how someone handles pressure over time. People who thrive on constant emergencies can look productive at first, but the better fit is someone who shares knowledge, documents decisions, and keeps the work from depending on one exhausted person. That difference explains why the role is still difficult to hire for. Many applicants can put together an impressive demo, but fewer can support the customer process once the excitement fades and the system has to work every day. The next step is to turn that hiring standard into onboarding. A structured handoff gives new people a repeatable path into their first deployment, so the team does not have to improvise the same lessons each time. Onboarding at scale is where an FD team proves whether it can grow without losing structure. The focus here is how to bring new people in fast while keeping the work repeatable, disciplined, and tied to product learning. That operational question comes first because early habits become the default later. If onboarding is loose, the team spends its time reacting to requests. If it is designed well, the team starts building a system that can be reused. A good program has to do all four jobs together. It needs to get people fluent in the product and the customer domain, help them reach value quickly, make ownership transfers clean, and turn what the team learns into something the whole organization can use again. Onboarding is where an FD learns to support the full deployment lifecycle, not just build a demo. The goal is to make the transition from prototype to production and from one engineer's work to a system the customer can actually own. Enterprise AI usually moves through a chain of stages. You need to understand how the customer already works, map the system around that workflow, build something small, test whether it is reliable, put it into production, and then transfer ownership cleanly so it keeps running after the original team steps back. That means training for the parts that are easy to miss when someone only thinks about model building. The real job includes delivery, reliability, and making sure the system survives contact with the customer's process. The first milestone is getting the customer to something useful quickly enough that they trust it. Early value matters because it creates momentum, but it also gives you real feedback before the system gets too large. A demo can look good without being durable. The hard part is turning that promising prototype into a business system that handles real traffic, real users, and real constraints. A good handoff prevents the customer from depending on one person forever. Documentation, ownership transfer, and support boundaries all matter because the deployment has to keep working after the initial team is gone. A working AI application is more than the model call. Prompts, retrieval, policy checks, logs, evals, and integrations all shape how the system behaves, so an FDE needs a clear map of those pieces. The workflow has to split responsibility carefully. Some steps should be automated, some should be reviewed by people, and some should escalate when the model is unsure or the stakes are high. Readiness should be decided with tests, not optimism. Explicit acceptance criteria tell you whether the system is good enough to ship and give everyone the same standard for approval. Once agents are involved, guardrails and monitoring become part of the job. You need to watch failure modes and define who can approve changes, because control matters as much as capability. That structure matters because new FDEs often have pieces of a job, but not the full operating picture. Onboarding connects software knowledge, AI knowledge, and the realities of business processes, compliance, and customer expectations. Salesforce's Ready in 6 is a useful template because it treats onboarding as a guided path to performance, not a stack of reading material. The point here is to see how training ends in something the company can actually use. The durable idea is simple. People learn best by doing a sequence of coach steps that finishes with evidence of readiness. When onboarding produces a deployment artifact, it proves the person can connect the material to real work. There are three reasons this structure works, and each one moves onboarding away from passive information toward usable skill. The first improves sequencing, the second builds shared context, and the third forces a concrete result. A curriculum gives new hires an intentional order. Product first, then customer conversation, then internal process, then deployment. Without that order, people spend energy figuring out what matters instead of learning the work. The intensive matters because it puts people in the same room with the groups they need to coordinate with, so they hear how experienced teams describe the work. That shared language makes later decisions faster because product, security, and solution teams are already working from the same mental model. A capstone should feel like a small deployment story, not an academic assignment. It asks for a scope problem, a working prototype, an evaluation plan, a rollout plan, and a handoff plan, so the company can judge whether the new hire can connect product, customer, and production reality. For a founder or executive, that is the practical lesson to keep. Strong onboarding does not just leave people motivated. It leaves behind proof that they can operate in the system and deliver a useful result. A 6-week onboarding timeline gives structure to the first days on a team and reduces the guesswork for everyone involved. The timeline turns a vague welcome period into a sequence of concrete checkpoints, so progress is visible and expectations stay clear. This part gives a concrete onboarding template for the first FDE cohort, so the process is no longer abstract. The goal is a repeatable ramp that teaches the product, the workflow, and the handoff in a way the company can actually manage. The value here is practical reuse. Instead of inventing onboarding from scratch, a team can start with a structure that makes the early weeks legible to both the FD and the manager. Six weeks is long enough to move from observation to ownership, but short enough to keep expectations clear. The sequence matters more than the exact calendar length. The FD starts by understanding the environment, then gradually proves they can operate inside it. Each week changes the level of responsibility. Early on, the FD needs context and vocabulary. Later, they need to show judgment, build something scoped, test it, and finally leave behind a system the team can carry forward without them. That sequence is the backbone of the ramp. Different companies may stretch or compress the timeline, but the learning order should stay familiar because it protects against a common mistake, treating a flashy prototype as proof of readiness. A scorecard turns onboarding into something a manager can evaluate consistently. Instead of relying on vague impressions, you define the 4 capabilities that matter at the end of the ramp. The point of a one-page format is focus. Managers should be checking the same few signals every time, so the cohort is judged on useful outcomes rather than on who talks the best or demos the prettiest mock-up. These 4 questions test the whole job, not just the technical slice. They check whether the FD understands the business workflow, can place AI in the right part of it, can prove the prototype with evaluations, and can leave behind something maintainable instead of a personal bottleneck. That simplicity is deliberate. Early FD teams fail when they mistake complexity for readiness. So the best scorecard asks for clear understanding, discipline building, and a clean handoff. The contrast here is between something that looks promising and something that can actually live in production. The point is to train the eye to see deployment readiness, ownership, and measurable value, not just a working demo. A good onboarding program should teach the new hire to spot that shift immediately. A solution can appear healthy in a demo and still fail when real users, real constraints, and real support are involved. Before FD involvement, the customer is often starting from a weak position rather than a finished system. That weakness may show up as a demo, a prototype, or an experiment that never made it into the business process. A demo can be convincing because it is carefully staged but may not handle volume, edge cases, or repeated use. What looks polished in front of a small audience can fall apart once real users depend on it. A prototype like that may technically work, yet nobody is responsible for keeping it alive. Without an operational owner, there is no one to handle support, reliability, or the next decision when something breaks. Some experiments stay isolated because they never connect to an actual workflow. If the tool does not fit approvals, handoffs, or day-to-day use, it remains interesting but not adopted. The failure is often deeper than code. Missing requirements, weak integration points, no evaluation method, no approval path, or no accountable owner can all stop a system from becoming real operations. Once FDE work starts, the difference should show up in the problem definition, the quality of the prototype, the handoff plan, and the feedback that reaches the product team. Those are the signals that the work is becoming deployable. The conversation shifts from a vague AI idea to a concrete workflow with users, steps, and a place in the organization. That reframing makes the problem easier to test and easier to own. A serious prototype needs standards for success. Acceptance criteria tell you what good looks like, and reliability checks tell you whether it keeps working when conditions are less forgiving. Deployment becomes sustainable when responsibility is explicit. Someone owns the system, someone knows how support works, and the handoff is written down so the work does not disappear after launch. The product team should not just receive a finished artifact. It should receive evidence. They need to know what worked, what failed, and which parts are strong enough to turn into product capability. Production success needs business evidence. Real usage, fewer manual steps, faster turnaround, fewer escalations, or higher completion rates. The exact metric changes by use case, but the discipline is always to tie the deployment to an outcome the organization can defend. That discipline keeps the role from becoming constant firefighting. A happy customer today is not the same as a system they can run independently tomorrow, and onboarding should make that distinction hard to miss. This vignette shows how FDE work starts with the customer's process, not with the model prompt. The point is to see how a prototype can fit real operations and survive contact with production. A request like this sounds narrow, but it touches the whole support flow. A summary tool only helps if it fits the pace, handoffs, and risk level of the team using it. A stronger onboarding step is to map the work before touching prompts. That means identifying ownership, routine cases, escalation paths, and the parts of the response where an automated draft would be unsafe or inappropriate. Once the process is clear, a small prototype can target the highest value pieces, summarizing the ticket, drafting a reply, and handing uncertain cases to a reviewer. Evals then answer the real questions: whether facts survive the summary, whether policy stays intact, and whether the reviewer actually gets faster without losing trust. That is the real transition. A tool is not finished when it works once. It is finished when it fits the customer's process and can be maintained after the pilot ends. FDE training has to build that habit from the start. Cost, ownership, incentives, and scale are the questions executives use to judge whether onboarding is a real operating capability or just an informal habit. The point is to connect training to margin, accountability, and growth. That means onboarding shapes how the company actually works, not just how new people are trained. It affects who does the work, how fast they become useful, and how much the system depends on a few experienced people. When the process is unclear, the cost shows up indirectly. New hires ramp slowly. Customers hear mixed messages. Work gets repeated, and senior FDs end up rescuing every hard deployment, which looks efficient in the moment but quietly eats margin. A structured process makes the role measurable. Once the work is visible, leaders can ask where time goes, who owns the function, and whether the model can be run efficiently at a larger scale. Cost is not just salary or training spend. The sharper measure is how long it takes before a new hire can complete a deployment with oversight, because that tells you how much capacity the onboarding process really consumes. Ownership affects priorities and behavior. An FD tied to product, engineering, go-to-market, or a dedicated field engineering team will be measured differently, and that reporting line changes what gets optimized. Margins improve when FDs turn recurring work into reusable patterns. If they're mostly filling in as expensive custom labor, the company is paying a premium for work that should have become standard. Incentives shape what managers protect. If people are rewarded only for saving deals, they may ignore handoff quality and product learning. If reuse and clean transitions matter too, the organization gets better over time. Scale asks whether the process works without exceptional individuals carrying it. A model that depends on heroics may handle a small load, but it breaks when the work volume grows or the strongest people are unavailable. These questions reveal whether the function can be repeated by the organization instead of improvised by a few experts. If a company never learns how to onboard FDs predictably, it usually cannot price the role well later because it has never isolated what the role actually produces. Some teams are too early for a formal FD onboarding program. The warning signs are product instability, a customer segment that is still too broad, or evaluation practices that are not mature enough to measure field work well. The risk is hiring people to operate in the field before the work itself is clear. If the team does not yet know the repeatable deployment pattern, the first hires can end up carrying the wrong mission. The answer is not to stop building structure altogether. Put in enough process to reveal what actually happens in deployment, but keep it flexible enough to change once the pattern becomes visible. This part boils the idea down to a simple standard. Onboarding only works if a new FD can explain the deployment lifecycle clearly and use it in a real customer situation without a senior person translating every step. That means the program has to produce independence, not just familiarity. If someone can repeat the terms but cannot connect them to an actual workflow, the onboarding has not done its job yet. At scale, the goal changes from teaching one employee to building something the organization can rely on every time. A good onboarding system creates consistent performance even when the original expert is not in the room. Once that capability exists, the real management question is maintenance. What it costs to keep it strong, and how to support it without treating training like a quota-driven sales process. That shift matters because healthy onboarding should build competence, not pressure. Compensation design is about matching pay to the real shape of the role, not the story people tell about it. For an FD, that means separating engineering leverage from sales pressure. A headline, a job posting scrape, and a company announcement can all point in different directions because they measure different things. The market looks bigger or smaller depending on which titles you group together and which sources you sampled. That matters because pay should follow the labor pool you can actually hire from. If the market is misread, the offer drifts toward the wrong model. Too sales heavy when the work is mostly technical, or too low when the scarcity premium is real. That is the right question to keep in view. An FDE should be shaped like a deployment role, not a disguised sales job with engineering language on top. The central choice is incentive design. If the role exists to build, adapt, and stabilize technical deployments, the compensation should reward that work rather than revenue urgency. An FD sits closest to product engineering and implementation work. So the clean structure is base pay plus equity. Variable sales style pay changes the signal and pulls the role toward commercial execution. Base salary covers the steady part of the job, the integration work, the evaluation setup, the debugging, and the coordination with technical stakeholders. Those tasks create the actual deployment capacity. Equity ties the person to the long-run value of the product. That makes sense when the job is about making a deployment stick and creating reusable product learning. A quota pushes the role toward rescue mode, where the person is rewarded for protecting revenue at any cost. Removing that pressure keeps the focus on sound deployment work. Skipping OE also keeps the role distinct from sales engineering. Once variable pay is tied to revenue outcomes, the incentives start to look commercial even if the work is technical. The difference is not cosmetic. A quota role says compensation should rise and fall with booked revenue, while an FDE role says compensation should reflect deployment quality, product learning, and adoption in production. A simple formula makes the logic visible before you start comparing offers and role bands. For an FD, total compensation is easiest to think about as base salary plus annual equity value. That structure says the company is paying for durable capability, not quarterly revenue pressure. A sales engineer is usually closer to the revenue engine, so the pay architecture shifts accordingly. That second formula makes the variable component explicit. It is a useful contrast because it shows how a sales-facing role is designed around booked business rather than deployment depth. These are not universal laws. They're a clean way to make the incentive structure easy to see when you compare role types. A package like 170K base and 40K in annual equity says the company is investing in deployment capability. If the same role carried a smaller base and meaningful variable pay, the job would start to tilt toward commercial execution. The next step is market anchoring. Good pay decisions come from understanding title fragmentation and local variance, not from copying one exact label. Job market data is useful when you treat it as a map of variation, not a single truth. It helps reveal how similar work gets priced differently across companies and title families. One company may call it forward deployed engineer, another applied AI engineer, and another deployment strategist. If you benchmark only exact title matches, you miss the people you are really competing against for talent. A workable process keeps the comparison set broad enough to be realistic and narrow enough to stay relevant. Start by grouping titles into a family, then separate base pay from total compensation. After that, adjust for geography for scarce production skills and for whether the job is truly customer embedded or mostly internal enablement. A role that mostly does architecture reviews should not be paid like a field-embedded deployment role. The time spent in customer environments and the level of delivery pressure should shape the band. A productized deployment motion shows why this matters. When the work is packaged as a repeatable offer, the compensation still has to match the actual behavior the company wants. The key distinction is between a repeatable deployment model and a pure consulting engagement. If the role is building production usage and feeding product learning back upstream, the pay model should support that. When a company packages deployment as an offer, it can be tempting to pay people like consultants or sales support. But if they are setting up workflows, teaching the customer's team, and instrumenting adoption, the incentives should reward those outcomes. The clean way to think about it is to reward the parts of the job that create durable value. Reliable delivery means the deployment actually works when customers depend on it. That is a technical outcome, not a sales outcome. Reusable patterns matter because they turn one hard implementation into a method the company can scale. That creates leverage far beyond a single account. Technical trust is what allows the customer team to actually use the system and rely on the person who deployed it. Without that trust, the rollout stalls. Feedback back into product is what turns field work into organizational learning. That is one of the main reasons an FD belongs in an engineering-style comp model. What should not be rewarded is closing behavior that pushes a customer into a fragile deployment. If the plan pays for speed at any cost, the company inherits the cleanup later. The compensation logic gets clearer when you compare the state of the account before and after the FD enters the picture. You need to know exactly what the role changes, because pay should follow the new value created by that change. First, think about the situation before the FD shows up. At that point, the customer may have something that looks good in a demo or pilot, but it only works in a controlled environment. The trouble appears once real data, real users, or real workflows enter the picture. That gap is what deployment work has to close. Often nobody owns the last mile between the model and the workflow. That missing ownership is exactly where an FDE creates value. After the FDE enters, the work becomes much more concrete and measurable. Now the role is building or adapting the integration, the evaluation loop, or the human AI workflow itself. That is engineering work with a customer context. Adoption can then be measured with real signals like active users, task completion, latency, error rates, escalation frequency, or throughput. Those metrics make the work visible. The final step is that product learning comes back in a form engineering can use. That closes the loop between field deployment and product improvement. That sequence is what compensation should reward. The company is paying for the ability to turn an unstable deployment into a repeatable operating pattern. At the leadership level, pay bands should be set by a few operational questions. Those questions tell you whether the role is truly scalable and where the real cost sits. Before setting the band, leaders should check cost, ownership, reporting line, and scale. Those four angles expose whether the role is being designed well. The first question is whether the role creates enough product learning and adoption to justify a premium over a standard software engineer. If it does, the pay should reflect that. The second question is ownership. If the FDE owns deployment outcomes, the role is substantive. If it is only a handoff layer for sales, the band should be lower and the structure different. Reporting line matters because it reveals what the company thinks the role really is. A home and product or engineering usually signals a technical role, while a go-to-market home often pulls it towards services. Scale is the last test. If the model only works when a few heroic people are available, the company is relying on talent instead of a system. In that case, compensation is not the only answer. The company also needs better tooling, clearer deployment architecture, and stronger internal support. A sales-style variable plan can make the numbers look neat, but it often just moves deployment complexity onto the individual. That is cost displacement, not real efficiency. For a first FDE team, there is a straightforward default that keeps the role aligned with the work. Start with a default that is competitive, but not distorted by sales incentives. Then adjust only when the role clearly behaves differently. Base pay should be benchmarked against adjacent senior technical roles in the same city or remote market. That keeps the offer grounded in the real labor market. Equity should reflect the long-term product value created by successful deployment. It is the part of the package that rewards durable impact. Avoiding quota language keeps the role from being interpreted as a revenue seat. The wording of the offer matters because it shapes both behavior and candidate expectations. If a bonus exists, it should be tied to deployment quality, reliability improvements, or documented product reuse. Those are system health outcomes, not invoice size. That last distinction matters. A bonus should reinforce the health of the deployment system, not the size of the customer bill. Before the offer goes out, a short checklist can catch most of the common design errors. A few direct questions will tell you whether the structure matches the role or has drifted into the wrong model. First, check the title family you are benchmarking against. An ATS label is often too narrow to show the real competition for talent. Second, compare base pay to base pay before you look at total compensation. Mixing those up makes offers look more or less competitive than they really are. Third, check what the offer actually rewards. If it quietly pushes deal pressure instead of production readiness, the structure is wrong. Fourth, ask whether a strong FD would recognize the job as technical and product-shaped. That reaction is a good test of whether the offer will attract the right people. Fifth, imagine how a sales leader would read the plan. If it looks like a quota path, the design is probably drifting toward the wrong incentive system. The rule is simple enough to hold on to when the details get messy. Pay the FD like a productized deployment engineer who works close to customers, not like a quota-carrying seller. Keep the model aligned with shipping, stabilizing, and feeding learning back into the product. That is the safest way to avoid importing a sales quota mindset into a role whose value comes from making AI work in the field. After the pay decision, the next problem is retention and burnout. Retention becomes the real test once a forward-deployed engineer function exists. The question is how to keep talented people from becoming the default cleanup crew for every customer problem. Hiring the first FD is only the beginning. The harder job is building a role that people can stay in long enough to learn, contribute, and grow instead of burning out and leaving. This is the burnout economy. The same qualities that make the role attractive can also make it exhausting. Visibility turns into constant urgency, and responsibility starts to expand until the engineer has no real boundaries. A clear definition matters because it sets the boundary. The role is meant to learn with the customer and bring those lessons home, not absorb every ownership gap the organization fails to cover. Three forces tend to push people out of the role: exhaustion, startup formation, and promotion away from the craft. Each one comes from putting strong engineers too close to pressure without enough structure around them. The patterns are easy to miss if you only look at headcount. When people leave, it is usually because the role itself is pushing them in one of a few predictable directions. Burnout starts when every customer feels like an emergency and every deployment has to move at full speed. The engineer ends up carrying the whole life cycle, from first discovery through stabilization and handoff, with no real relief. One difficult account is manageable. What breaks people is repeated context switching with no recovery period, where every week brings a new stack, a new stakeholder group, and a new definition of success. The same closeness that helps the company can also train someone to spot the next company. FDEs see product gaps, buying urgency, and painful workflows before most teams do, so founding a startup can become a very natural next step. That outcome is not a failure by itself. It becomes a retention problem only when the role offers no path for ambitious people to keep growing inside the company. Another common pattern is promotion. Once someone understands the customer, the product gaps, and the failure modes, they are obvious candidates for broader leadership roles. That move is healthy when it's planned. It becomes a retention issue when the only way to be recognized is to leave the FD craft role behind. The fix is not perks or slogans. Sustainable retention comes from designing the work so that people can do it well without being consumed by it. Mission alone does not solve overload. The function has to be structured so the work feels bounded meaningful, and repeatable enough for strong engineers to stay. A career ladder gives people a reason to stay and a way to grow. Without it, high performers will look elsewhere for a path forward. If progression is invisible, the strongest people will assume the function is a dead end. That is usually when they start planning an exit. The ladder should show real stages of growth, owning deployments, coordinating across accounts, influencing architecture, shaping product decisions, and eventually moving into principal or team leadership scope. That matters because this role sits between engineering and customer work. Ambiguity can look like low prestige unless the company makes the progression path explicit. Rotation keeps the role healthy. It prevents the engineer from getting trapped in the customer's urgency and helps preserve the product judgment that makes the role valuable. Embedding is useful because it closes the gap between the field and the team. But when it never ends, the engineer stops translating between worlds and starts patching the same customer forever. A return to the core team gives the engineer a different kind of problem to solve, which lowers fatigue. It also turns field lessons into reusable product decisions instead of private knowledge trapped in one person's head. That is the point of rotation. The engineer should not be locked into one customer's urgency forever. The role has to create leverage for the business, not only more work for the individual. Rest has to be part of the operating model, not an afterthought. A deployment cycle that never allows recovery will eventually produce the same burnout it was supposed to avoid. The reset window is part of how the work gets done. It is not something earned only after exhaustion has already set in. After a major launch, there should be a lighter period built in. That could be internal work, smaller accounts, or product hygiene tasks that give the engineer time to reset without falling straight into another high-intensity engagement. Enterprise AI often hides the real effort behind a fast demo. The team still has to deal with integration, review, alignment, and hardening, so rest periods are what give the deployment real closure. A concrete deployment makes the pattern easier to see. The difference between a healthy and unhealthy FD function shows up very clearly once you follow a real customer workflow from prototype to production. A document workflow is a good example because it usually looks simple at first and then reveals real operational complexity once it reaches production. A demo can hide messy input formats, permission problems, and low trust from the business side. Adoption stays low when the prototype has not crossed into the customer's real workflow. The FDE changes the job from abstract model work into field work. The engineer studies the real process, finds the failure points, narrows the use case, and adds the guardrails needed for safe production use. The learning should not stay local to one deployment. The core team needs to turn those field lessons into roadmap decisions and reusable product pieces. A phrase like ready in 6 only works when the motion behind it is repeatable. If the same small group is always scrambling at the end, the system becomes a burnout engine instead of a reliable deployment process. The unhealthy version is easy to spot. One engineer keeps getting pulled into the next account before the first one is truly handed off, and the company quietly builds a fragile dependency around that person. A simple comparison makes the operating model visible. When you line up healthy and unhealthy behavior side by side, the retention logic becomes much easier to judge. The table captures the difference between a function that scales and one that quietly consumes people. Each row points to the same question. Does the role create clear, bounded work or open-ended rescue duty? That is the core retention logic. Engineers stay when the work has purpose, has limits, and is visible enough that their contribution is understood. Handoff is not just an operational cleanup step. It is one of the strongest ways to protect engineers from becoming the permanent owner of every customer edge case. A handoff decides whether temporary support becomes durable ownership elsewhere or just piles onto the same FD again. That makes it a people problem as much as a process problem. A real handoff transfers the deployment into a stable operating state. It needs documentation, stakeholder alignment, clear escalation paths, and a shared definition of success so the engineer is not left holding every edge case. The details are practical, not abstract. A strong handoff has to answer who owns the deployment, how the work is documented, what the product team learns, and when the FD should re-enter versus step back. Someone inside the organization has to own the outcome after the FD steps away. Without that named owner, responsibility just slides back to the engineer. The workflow has to be written down in language the team can actually use. Plain documentation is what lets the deployment survive beyond one person's memory. The field should feed the roadmap. If the learning stays in a private notebook, the company keeps paying for the same lesson over and over. The team also needs a clear threshold for coming back in. If every minor issue counts as re-engagement, the FDE never really exits the account. When an engineer stays on call for everything, the company has not built a function. It has built a dependency that looks efficient until the team is overwhelmed. At the leadership level, retention connects directly to margins and scale. The way the role is structured changes not only how people feel, but also how much each deployment costs. It is not one or the other. If the model is unhealthy, even good managers will struggle to keep strong people because the structure keeps pushing them toward overload. If every deployment has to be rebuilt from scratch, the work starts to look like custom consulting. That hurts profitability, and it also signals to engineers that their time is being spent on repetitive heroics instead of reusable product work. The reporting line changes the incentives. A sales line can pull the team towards speed and deal support, while a product or engineering line can pull it toward learning and platform reuse. That is the question executives have to answer honestly. One model scales because it creates a repeatable engine. The other burns people out because it asks a few engineers to absorb every customer exception. The market side follows the same logic. Ambitious people are drawn to roles that teach them fast, but they will only stay if the job is clearly defined and technically serious. That steep learning curve is exactly why the role attracts strong candidates. It builds product judgment, customer intuition, and deployment ownership very quickly, which can also make the person attracted to startups and leadership roles elsewhere. So hiring is not just about volume. The best people compare environments carefully, and they will avoid a role that sounds strategic on paper but behaves like an endless support queue in practice. The simplest rule is the one leaders should remember. If the role cannot help people finish, recover, and grow, retention will keep getting worse no matter how good the hiring is. Keeping FDs means building a system around them, not just asking for more effort at the customer edge. The function has to make completion and recovery part of the job. That system rests on a few concrete pieces: a real career ladder, rotation back to core product, deliberate rest periods, and handoff rules that stop the engineer from becoming the permanent owner of every deployment. The next problem is even sharper. Once the function starts drifting into low-margin consulting, the same retention pressures get harder to contain because the role loses both leverage and clarity. The real issue here is whether customer work feeds the product or just consumes the team. The goal is to keep forward-deployed engineering tied to reusable product improvement, not custom labor. That question separates useful customer engagement from one-off support. If the answer is yes, the work is changing the product in a lasting way. If not, the team may just be patching the same gap repeatedly. A team can look productive while drifting into custom fixes and glue code for one account after another. The danger is that the company gets better at serving individual customers, but worse at building a repeatable product, and that trade-off shows up as service debt. This part shows the pattern where customer work starts to look like consulting instead of product improvement. The important question is whether the deployment teaches the platform something reusable or just satisfies one account and disappears. When the scorecard focuses on pleasing the customer, logging effort, or winning revenue, the engineer can look successful without making the core product better. That creates a dangerous gap. The business gets motion, but the product does not compound from the work. The sequence is easy to miss when you are close to it, because each individual decision feels practical. The problem appears only when the same kind of workaround keeps getting rebuilt. It usually starts with a real customer need. The request is legitimate, but it also reveals a product gap that the team has to decide whether to solve once or solve repeatedly by hand. A fast custom build can be the right move in the moment, especially when adoption depends on it. The risk is that speed hides the fact that the team has chosen a temporary fix instead of a capability. This is the turning point. If nobody converts the workaround into product work, the organization learns only how to ship exceptions, not how to reduce them. Then the same demand shows up again, and the team reaches for the same custom solution. At that point, the work is no longer a rare exception. It has become a pattern of rebuilding the same thing. That is how a shadow services team forms inside a product company. The people may be engineers, but the economics resemble consulting. Each engagement starts from scratch, and the organization gets very little reusable learning from the repetition. A concrete example makes the difference easier to see. The healthy case and the unhealthy case can look similar at first, but they diverge based on whether the product changes after the first deployment. A regulated buyer often needs more than a demo-ready model. The FD has to connect the product to approval flows, permissions, logging, and review steps so the system can fit the customer's real operating rules. The kind of work is valuable when it turns an abstract product into something the customer can actually adopt. The key is that the deployment feeds back into the product boundary instead of living only in one account. The unhealthy version starts when the original fix never gets absorbed into the platform. Every new customer needs the same choreography, so the engineer is no longer extending the product. They are carrying an internal consulting backlog. Product-shaped work shows up when customer success also strengthens the core product. The real test is whether the engagement leaves behind something reusable, not just a completed project. A healthy organization does not rely on memorable one-off wins. It uses a steady check to see whether each engagement is creating value that can survive beyond the immediate customer need. Three signals matter together. The customer got value, the product team learned something reusable, and someone inside the core team is responsible for carrying it forward. That combination means the work is contributing to the product, not only consuming engineering time. If the work stops at customer delivery, it stays in service mode. When delivery also creates learning and ownership, the organization starts to compound its effort and behave like an FD team. A short review rhythm keeps drift visible. These questions force leadership to look past activity and ask whether each engagement is leaving behind something the company can reuse. The point of the cadence is to catch a service pattern before it hardens. Each question probes for roadmap impact, reuse, learning, and ownership. A useful engagement should alter priorities, not just consume capacity. If the roadmap never changes, the work may be solving a local problem without improving the product direction. This gets at reuse. If nothing carries over cleanly, the team is rebuilding the same solution for each account instead of turning it into a product capability. That question turns delivery into feedback. The best field work teaches the team something about the product's limits, assumptions, or missing pieces. Some requests belong to one customer, and some are early signs of a broader need. Distinguishing the two keeps the team from overgeneralizing a one-off issue or ignoring a pattern that keeps returning. Ownership has to survive the engagement. If the fix has no clear owner after the field engineer steps out, the organization has only created a temporary patch. That question tests whether the account depends on one person or on a real system. When progress can continue without the engineer, the team has built transferability instead of personal dependency. A solution helps one customer. A pattern helps many. When a team converts an engagement into a pattern, it creates leverage that the next deployment can use immediately. That is the deeper test. Good organizations do not just finish work. They keep reorganizing what they know so the next engagement starts from a better place. Where the FD sits shapes the job itself. The reporting line, incentives, and decision rights decide whether the function feeds product learning, helps close deals, or gets pulled into general support work. Org design is the way responsibility is split up inside the company. And for FDs, that split is decisive. A weak structure makes the role drift toward the nearest pressure point instead of serving the long-term product. A services-heavy setup pushes the team to satisfy the last request in front of them, so the work stays tactical. A setup that is too far from product leaves field engineers solving the same customer problems over and over without changing the underlying system. A stable FD structure needs 3 reference points. One keeps the team connected to product, one keeps it aligned with go-to-market motion, and one keeps ownership boundaries clean. A strong line to product means the things field engineers learn can actually change the roadmap. Without that link, the team collects useful insight that never reaches the people deciding what gets built. The operating link to sales or customer success keeps the team focused on the right accounts and deployments. That connection helps FDs spend time where the business impact is real, not just where the loudest request comes from. Clear boundaries stop the FD from becoming the default owner for every technical problem. Implementation, support, and customer engineering each need their own lane, where the role loses focus and becomes impossible to scale. The reporting line can change from company to company, and that part is less important than the incentives around the role. If the FD is rewarded for being the universal fix-it desk, the structure will pull the function away from its real purpose. Hiring signal means the evidence that predicts whether someone will do well in the role. For an FD, the real question is not whether the person can handle anything, but whether they can turn messy customer reality into something repeatable and useful. That distinction matters because broad competence can hide the wrong strengths. An effective signal shows whether someone can move from a specific customer problem to a product improvement that can be used again, not just solve the one case in front of them. Portfolio proof is useful because it shows judgment in real conditions. A migration plan, a deployment note, a design memo, or a before and after example can reveal much more than polished presentation, especially when the work shows how a one-off request became a reusable pattern. That is the deeper test for leaders. Some candidates interview smoothly, but the stronger signal is the person who can explain what should be generalized for the next customer, because that shows product thinking instead of only service skill. Career changes often bring the right mix of technical depth and customer instinct, but they also make evaluation harder. The challenge is separating someone who can support an account from someone who can create leverage for the whole product. A former consultant may be excellent at keeping ambiguity under control, and a former engineer may be excellent at building durable systems. The role needs both instincts, but the signal should tell you whether the person can convert that background into reusable value. That final question cuts through a lot of noise. The best candidates leave behind something that makes the next engagement easier, faster, or more reliable, while weaker fits only keep the current relationship afloat. Interview loop design should tell you whether someone can make decisions that scale beyond the immediate request. For FDE hiring, the goal is to probe for reusable thinking, not just a polished reaction to a single customer problem. The structure of the hiring process matters because it shapes what candidates can show. If the rounds mirror real FDE work, you get a much better signal on how they handle ambiguity, customers, and product trade-offs. A balanced loop usually spreads the evaluation across several kinds of judgment, so one strong skill does not hide a gap in another. Each round should test a different part of the job. Technical depth matters because the person still has to reason about systems, constraints, and implementation details. This round checks whether they can go beyond surface answers. Customer scenarios reveal how the candidate chooses what matters first and how clearly they explain that choice. Strong FDEs can stay organized when the problem is messy and the customer is under pressure. Product judgment is where you learn whether they can spot the difference between patching a single case and improving the platform. That distinction is central to FDE work because every custom fix has a cost. Collaboration matters because FDEs sit between teams and have to translate needs in both directions. The best candidates can work with product, sales, and customers without losing the technical thread. A good simulation gives the candidate an incomplete but realistic situation and asks for judgment, not perfection. For example, a deployment story can reveal what they would do first, what they would escalate, and what they would try to turn into a product change. The point is to watch for systems thinking. They connect the immediate fix, the team response, and the longer-term improvement. That usually separates someone who only reacts from someone who learns from the work. A concrete prompt helps interviewers test the same judgment in a consistent way. It should force the candidate to weigh a quick workaround against a broader change. A prompt like this opens up trade-offs without pointing to a single correct answer. It gives the candidate room to show how they reason. This question tests whether the candidate can separate urgency from leverage. A strong answer shows how they evaluate scope, ownership, and whether the solution should stay local or become part of the platform. A strong response names the trade-offs clearly, assigns the right owner for each next step, and keeps the learning from disappearing into a one-time fix. When someone jumps straight to custom code, that usually means they're solving the symptom instead of the underlying pattern. Onboarding sets the boundaries of the role. If the early process is vague, the FD inherits every unclear problem, and that is how overload becomes normal. A new FD needs explicit knowledge of the product, the customer environment, the handoff process, and the escalation path. When those pieces are missing, the person joining the team ends up owning whatever no one else has defined. Rest matters, but the larger issue is whether the job keeps absorbing ambiguous work. If every unclear task lands on the same person, burnout is built into the structure of the role. The early ramp should teach both the technical flow and the limits of responsibility. That keeps a new hire from learning the wrong habits under pressure. Watching real deployments shows how issues appear under pressure and how experienced people respond. It gives the new engineer a practical model before they are expected to lead one. Past cases reveal which customer problems kept coming back and which fixes were turned into durable product work. That history teaches the difference between a one-off rescue and a reusable solution. The FD should know exactly who picks up the product side of the work. That contact prevents the engineer from carrying permanent ownership of fixes that ought to live elsewhere. The goal is to separate a field workaround from product work in a clear, respectful way. If someone can say that out loud early, it becomes much easier to avoid taking on every temporary workaround as a long-term duty. Good boundaries depend on knowing which team should own which kind of issue. That keeps the FD focused on the highest value technical work instead of becoming the first stop for everything. The first few months send a strong signal about what behavior the company values. If late-night customer patching is the only hero story, people will learn that exhaustion is part of success. A short handoff checklist gives the team a way to finish work instead of endlessly reopening it. It also makes the reusable part of the job visible to other owners. Simple questions can force a clean handoff. They make the team spell out what was solved, what can be reused, and what still needs a real owner. Start with the concrete problem, not the workaround. If the problem is not named clearly, no one can judge whether the same pattern will matter again. This question separates durable learning from one customer's local fix. Anything reusable should be pushed toward product or enablement, not left inside a single engagement. Some pieces should stay custom, but the reason has to be explicit. That forces the team to justify exceptions instead of treating every special case as normal. A reusable fix is not finished until another owner accepts it. That transfer is what turns field knowledge into something the product team can actually maintain. Documentation is part of the handoff, not an extra if time allows. It gives the next person context without forcing the original engineer to stay attached to every detail. A transfer is incomplete if the next team cannot actually use the fix. Training closes that gap by making sure the knowledge is usable, not just written down. When the checklist cannot be answered, the work has not really left the FDE's lap. That usually means the company is treating the relationship as ongoing consulting, even if the title says something else. Salesforce is ready in 6 framing shows a simple organizational idea. Field work should create speed, repeatability, and adoption, not just one-off customization. The important part is the design principle behind the branding, because that principle tells you how a product company uses frontline work to build a reusable playbook. That shift matters because the goal is no longer to solve one customer problem once. The goal is to shorten the path to the next deal and preserve the steps that make delivery reliable. A consulting shop is paid to finish a single engagement, so the work stops when that project ends. A product organization uses the field to improve the next sale, the next deployment, and the next handoff, so each customer interaction becomes part of a larger system. The same pattern shows up in partner-led delivery, especially in cloud ecosystems like AWS. Strong teams push repeatable pieces outward through templates and reference architectures, Then keep a clear line between what should be customized and what should remain product-like. That balance becomes even more important when the role is deeply embedded with customers, as in many forward-deployed models. Proximity can easily turn a product motion into a service motion, so leadership has to protect the feedback loop and keep the team tied to product learning. Cost, ownership, margins, and scale are the executive lens on this problem. The real question is whether field work stays a one-off expense or becomes a repeatable part of the business. When custom work keeps piling up, it does not just create friction for teams. It eats margin because every exception consumes time, and it hurts scale because each new customer pulls the organization into another bespoke path. Context switching makes engineers slower because they keep jumping between unique situations instead of building reusable patterns. The hidden cost is ownership. If nobody can point to the reusable fix, the company pays once to satisfy the customer and again to rebuild the same knowledge internally. Reporting lines and incentives shape behavior very directly. If people are rewarded only for immediate customer satisfaction, they drift toward more custom work. If they are rewarded only for roadmap speed, they avoid the field work that reveals what should change. The right model values both outcomes together. A few strong field engineers can carry a small number of accounts, but that does not make the system scalable. Scale comes from clear rules for when to turn repeated work into product, when to leave it local, and when to hand it off so ordinary teams can make the same judgment well. The point here is a simple test for whether an FD function is building long-term value or just completing customer work. If the function is designed well, every engagement should leave the company with more capability than it had before. That means the work cannot stop at a successful deployment. The company should come out of the project with new knowledge, better tooling, or stronger patterns that can be reused later. At the end of each project, that question forces a concrete answer. Maybe the product changed because an edge case became a feature. Maybe the playbook changed because the team learned a better process. Or maybe the roadmap changed because the field uncovered a real priority. A result by itself is not enough. An FDE organization turns field experience into internal capability, and without that conversion, the company is just doing professional services under another name. Once the role is built around learning and product impact, pricing becomes a separate design problem. The real question is how to charge for the function while keeping it tied to the product, not to an open-ended services model. Pricing FD work is really about drawing the line between product support and a services business. The decision matters because the pricing model shapes how the team behaves, how finance evaluates it, and what the rest of the company thinks the team is for. A founder or CFO usually wants to know how to defend the team inside the company, not just what number to put on an invoice. If the team starts sounding like consulting, it becomes easier to treat it like a revenue line instead of part of the product engine. Hourly billing changes the incentives immediately. Once utilization becomes the scorecard, the team starts behaving like a services group, chasing billable time and contract milestones instead of building leverage for the product company. That can look organized in the short term while pulling the organization toward the wrong economics. The first question is how the work should be classified, because that changes the story the business can tell. If FD time is treated as R&D, the spend connects to learning and product improvement instead of being trapped inside delivery cost. The useful internal argument starts there. The value of FD work is not just the customer ticket in front of you. It is the capability you build while solving it, and that makes it fit the research and development frame much better than pure delivery cost. Once you use that lens, the distinction gets much clearer. The point is not whether the work helps a customer. The point is whether the work creates reusable knowledge or tooling that improves the product and the deployment process. R&D is the part of the work that explores a failure, tests a fix, and turns the result into something repeatable. That could become better integration logic, better onboarding, or a tool that reduces the same problem next time. COGS is different because the task is already understood and the main job is execution at a stable margin. If the work does not teach the team anything new, it belongs much closer to that delivery bucket. An FDE can start on one account and still generate lessons that apply everywhere else. The real job is to find why the deployment is breaking, correct the pattern, and feed that improvement back into the product, the docs, the tooling, or the onboarding flow. That is why a pure services pricing model misses the point. Services pricing sells time, but FDE pricing should reflect the product and process gains created by that time, because that is where the durable value lives. Unit economics in an FDE org means measuring value against the cost of specialized effort. The important question is not how busy the team looks, but whether each effort creates reusable impact that compounds across customers and products. That question forces a trade-off view. Every team action should produce something valuable enough to justify the time, expertise, and context switching it consumes. For an FD team, the unit is usually an outcome that changes the customer situation or improves the product system. Hours matter for planning, but they're not the real economic unit because the business cares about results that can be reused. A faster deployment creates value because it shortens time to revenue, time to learning, or time to adoption. The team is earning impact by removing delay from the path to production. Removing a blocker has value because it unblocks progress that would otherwise stall. One solved issue can unlock a whole chain of implementation work. When a pattern gets generalized, the team turns a one-off fix into something repeatable. That is where the economics improve, because the same thinking can serve many cases instead of only one. A reused playbook lowers the cost to the next project. It means the team's effort is leaving behind structure that makes future work faster and more consistent. Clarifying a requirement can be just as valuable as writing code because it prevents wasted implementation and rework. Good discovery work often saves more money than it spends. That is the economic test. If the team keeps creating assets, knowledge, and product improvements that outlive the original task, the organization gets leverage instead of just labor. A useful manager statement should translate the work into business outcomes. It shifts the conversation away from staffing and toward the effects the team is actually buying. That phrasing captures the real return. The organization is paying for fewer mistakes, quicker customer uptake, and better product learning, which is much closer to the value an FD team creates than raw hours ever are. That is why internal charging models often break down. They start with a cost unit that looks precise, but the organization has not yet defined the value side of the equation, so the pricing model floats free of the actual outcome. This part gives a practical way to frame the decision in business terms: value created versus cost incurred. The goal is not perfect accounting, but a clear model that helps leadership judge whether the work is worth funding. A rough ROI model is often more useful than a polished number that hides uncertainty. It forces the conversation onto the two things executives care about most: what the effort produces and what it consumes. The formula compares the recurring value against the spend required to get that value. If the numerator is positive, the work is paying back more than it costs. If it is negative, the deployment is draining resources. The terms underneath matter because they keep the model grounded in real business effects rather than abstract theory. Annualized value is the benefit that keeps showing up after the first project is done. Faster activation, better retention, fewer support escalations, and reusable product work all turn one effort into repeated gains. Deployment costs should include the full cost of making the work happen, not just salary. Once you add tools, travel, and the engineering time spent supporting the engagement, the real expense becomes much clearer. That distinction matters. The point is to guide a choice when the numbers are uncertain, not to pretend the first estimate has the rigor of a finance model. A 6-week engagement may look expensive if you only count labor, but the larger payoff can come from what gets reused later. If one integration template shortens 5 future deployments, the original effort is no longer just a cost center. It has created leverage for the next round of work. That is the same trade-off behind many engineering decisions, except some immediate inefficiency when it creates a capability that compounds over time. Executives usually understand that once the future savings or revenue are made explicit. SOWs and SLAs work well when the work is already known, but they can steer an FD team toward the wrong goals when the real problem is still being discovered. A statement of work ties the team to a fixed delivery plan. That makes sense for bounded work, but it can become too rigid when the problem itself is still changing. A service-level agreement focuses on measurable service quality. That is useful for stable operations, but it does not tell you whether the customer actually got the result they needed. Both structures have a place. The problem starts when they become the main way to judge FDE work, because then the team gets rewarded for compliance instead of for learning what really solves the customer's issue. That frame usually pushes teams toward accounting questions instead of problem-solving questions. Hours tell you effort, not progress. A team can spend a lot of time and still miss the real constraint. Finishing a deliverable can feel like success, but the deliverable may still leave the customer unable to use the system in practice. Milestones are helpful when the path is clear. They are less helpful when the team needs to learn, adjust, and uncover the real blocker along the way. If the scope is stable, those measures keep everyone aligned. The trouble is that FD work often begins before anyone knows the full shape of the solution. A model prompt may not be the issue at all. The data pipeline may be broken, or the integration may be technically correct while the workflow still feels too awkward for people to adopt. So the visible task gets done, but the hidden constraint remains. Outcome-level agreements shift the conversation from activity to results, which is a much better fit for deployment work that has to prove real business value. An outcome-level agreement focuses on whether the deployment changed something meaningful for the customer. It measures outcome, not just effort or task completion. That question matters because it keeps the work tied to shared value. It does not replace every contract, but it does set a clearer target for collaboration than hours or isolated deliverables. Once the target outcome is clear, the agreement can describe the behaviors and results that prove the deployment is working in the real environment. The comparison changes the center of gravity. Instead of paying for labor and checking off scope, the team is judged by whether the customer actually gets the result, while the learning from the deployment gets captured and reused. A useful OLA is concrete enough to verify, but still broad enough to keep the team focused on the business result rather than on a narrow task list. That tells you the workflow is real enough for regular users and that the system is not depending on hidden human support to keep running. That checks whether the solution is resilient. A deployment that breaks every time the customer changes a field or format is not truly operational. That part matters because FDE work should produce something repeatable, not just a one-off rescue. Good work leaves behind a pattern others can apply. That closes the loop with product. The team is not only solving the current case, it is identifying what should become a broader product improvement. That is the shift to keep in mind. The goal is not visible activity for its own sake. It is measurable movement toward the outcome that matters. Ready in 6 is a good anchor because it shifts attention from effort to speed of adoption. The useful question is not how many hours a team spends, but how quickly customers reach real value. That message works because it points leaders toward a management problem: how to make progress visible and defensible. A slogan like this gives a simple way to talk about operational value instead of staffing effort. A customer funds this work when it shortens the path to outcome. If the team can show less time to launch, fewer adoption blockers, and less rework, the role becomes much easier to justify inside the business. Without that kind of help, a promising pilot often gets stuck in the gap between intent and production. The pattern is familiar, the idea is strong, but the implementation details slow everything down. The customer starts with a credible use case and real enthusiasm. At this point, the opportunity is there, but it has not yet been tested against the customer's actual environment. Then the first hard edge appears. A system connection does not behave as expected, where the data model is not what the team assumed. Small mismatches like that can stop momentum very quickly. At that stage, broad advice is usually not enough. The customer needs help that fits the specific architecture and workflow, not a standard answer pulled from a handbook. While the team keeps trying different fixes, time passes and the project loses energy. That delay matters because adoption is often fragile. Once people stop seeing progress, commitment drops. Once FD steps in, the work becomes much more grounded. The focus shifts from guessing in the abstract to solving the deployment inside the customer's real conditions. The first move is to inspect the actual setup, not an idealized version of it. That matters because the real constraints usually explain why the pilot stopped moving. From there, the team adjusts the path so the system can actually work in practice. Sometimes it means building something new. Sometimes it means reshaping an existing approach so it fits. The metric changes too. Intent is not enough because people can say they plan to adopt a tool without ever putting it into regular use. The last step is what makes the role valuable beyond one account. When the team turns a solved customer problem into a repeatable pattern, product, and enablement can use it again elsewhere. That in-between position is the point. FD has to understand the customer deeply enough to solve deployment problems, while also turning those solutions into reusable knowledge for the company. This part focuses on the real executive risk, not whether senior engineers cost money, but whether the team starts losing margin by doing custom work over and over with no reusable payoff. Senior engineers will always be a meaningful expense, so cost alone is the wrong alarm. The question is whether that expense produces leverage through repeatable work or whether it disappears into one-off fixes. Margin risk appears when the team stops building compounding assets. If every engagement turns into a bespoke rescue, the organization is paying senior talent rates for work that never gets easier the second time. The pattern is easy to spot once you know what to look for. It shows up in the way the team is rewarded, what gets owned after delivery, and whether fixes ever escape the one customer who needed them. When every deal needs its own engineering, the team is no longer amplifying the product. It is acting like a bespoke services shop that can close deals, but it does not build a scalable operating model. If no one owns the artifact, the knowledge disappears with the project. Reuse only happens when somebody is accountable for turning a one-off fix into something the next team can pick up and apply. Praise shapes behavior. If the only reward is account rescue, people will keep solving the same class of problem in the hardest possible way instead of investing time in a general fix. Customer delight matters, but it is incomplete if nothing transfers into product or into a playbook. Without that transfer, each win stays local and the organization keeps paying for the same lesson again. Heroics are a warning sign because they hide the absence of process. Once the organization depends on exceptional people solving exceptions, the system stops learning and the margin starts eroding. Reporting structure pushes the team toward different habits. Sales can pull it toward deal speed, support can pull it toward ticket closure, and product can pull it away from customers. The better structure is the one that keeps the bridge function intact while making reuse easy to see and reward. That means the real decision is organizational, not merely financial. The cost of the team matters, but the deeper question is whether the structure produces repeatable value or traps the company in perpetual custom work. The useful question is not how many hours the team sold, but whether the work made the product and the customer smarter. These measures show whether the team is building leverage instead of acting like a temporary services shop. A learning engine improves the company every time it works with a customer. That means the metrics should reward speed, reuse, and product knowledge, not just time spent. The dashboard should combine delivery outcomes with learning outcomes. That way you can see whether a deployment helped one customer and also improve the system for the next one. Shorter time to first value means the customer is getting something real into production quickly, not waiting through a long setup phase. It is a direct signal that the team can turn effort into impact. Reuse rate tells you whether the work leaves behind something durable. If an artifact becomes a template, a playbook, or a product fix, the team is creating assets that help future work move faster. Escalation reduction shows whether the process is getting cleaner over time. If later deployments need fewer one-off interventions, then the team is learning how to make the work repeatable. Adoption quality looks past launch day. A workflow only matters if the customer keeps using it. So this metric checks whether the solution fits real behavior instead of just passing a demo. Product learning output is the strongest sign that the deployment changed the company itself. A roadmap item, a documentation change, or a tooling improvement means the customer work fed back into the product. That kind of output is the bridge from services thinking to product thinking. The customer project stops being a cost center activity and starts generating knowledge that belongs in research and development. Hiring for FDE work is really about judgment under ambiguity, and that same judgment also protects the team from overload. The focus here is how to recognize that signal, how to interview for it, and how unclear boundaries can turn into burnout. When the role can drift into doing whatever the customer asks, people need a clear line for what belongs to the FD team and what is not. Without that line, onboarding becomes guesswork and the role expands by accident. Technical depth matters, but it is not enough on its own. The real signal is whether someone can sort an issue into the right bucket and choose the right level of response. Some problems are best handled right where they appear. A strong candidate can tell when a small repair solves the issue without pulling in a bigger process or a broader team. Other problems reveal a pattern. In those cases, the useful move is to turn one-off effort into something reusable so the same issue does not keep coming back. Some cases need more authority, more context, or a different owner. Judgment means knowing when the right action is to raise the issue instead of trying to absorb it yourself. And some requests should be declined. If the work does not move the business forward, taking it on can waste time and distract the team from higher value problems. That changes how interviews should be built. Fast coding can be useful, but it does not show whether someone can make good decisions in messy, real-world situations. A balanced loop should sample the kinds of decisions the job actually requires. The point is to see how the candidate thinks when the problem is ambiguous, technical, and tied to customer impact. A failed deployment can reveal product thinking. A debugging exercise shows how they work through systems problems, and a messy customer request exposes prioritization skill. The handoff question matters too, because strong FDs do not just fix, they document, teach, and sometimes turn the fix into a product requirement. Burnout starts when every ambiguous edge case lands on the same person. A healthy organization sets criteria for deep intervention so the team can focus on the work that truly deserves it, instead of living in constant heroic context switching. A deployment decision test gives the team a quick way to tell whether an FDE effort is building durable product value or just handling requests. The point is to force clarity before the work scales. For questions are enough to expose whether the engagement has a real path to adoption and reuse. Each one checks a different part of the value chain: the problem, the change, the measurement, and the return to the company. Start with the failure mode, then ask what the FDE team actually changes in the customer workflow or the product itself. After that, look for a concrete adoption signal, because without one you cannot tell whether the work sticks. The last question matters just as much. If nothing reusable comes back, the effort may help one customer but leave the company no stronger. That threshold is a useful guardrail. When the answers are weak on most of these points, the organization is probably paying for custom help rather than building a capability it can repeat and scale. Role definitions shape the market. If FDEs are described as narrow pre-sale support, the job starts to look disposable. If they're described as product and deployment work with measurable outcomes, the role attracts engineers who want real ownership. That framing changes who applies. Engineers with ambition tend to avoid jobs that sound like constant handoffs and short-term support, and they lean toward roles where the work connects to product decisions, implementation, and results that can be measured. Retention depends on that same feeling of progress. People stay when each project builds their skills, their influence, or the customer relationship, instead of resetting to zero every time. The practical rule is simple. FDE cost only makes sense when the work creates something that compounds. The value has to show up as a repeatable deployment pattern, a product insight, or a measurable adoption gain. A single engagement should leave behind more than a billable hour count. It needs to produce a pattern you can reuse, information that improves the product, or evidence that customers are adopting faster. When none of those outcomes shows up, the model starts to look like consultancy work. You're paying for hands-on labor, but not for an asset that gets stronger over time. That boundary matters because the decision is not only how to staff the function, but whether the function belongs there in the first place. If the economics, maturity, or customer profile are wrong, the better answer is often not to build it. Some deployment problems are real, but they do not automatically justify a new FDE function. The question is whether the company has the conditions for that role to compound, or whether it would just add cost and complexity. The useful distinction is between needing help on a deal and needing a permanent operating function. A strong company has to decide whether the problem is big enough, repeated enough, and strategic enough to support embedded engineers. An FDE team pays off only when customer work feeds back into the product and the revenue can carry the cost. If those inputs are missing, the role still looks useful day to day, but the business does not get a durable capability from it. These are the conditions that should make leadership pause. Each one points to a company that probably needs better product motion before it needs embedded engineering. Each of these flags means the same thing in different ways. There is not enough room for FD work to create leverage. If the sales motion is fast, the contract is small, or the product already stands on its own, the organization is likely solving the wrong problem by hiring FDEs. The point is to stop a premature build. A company often reaches for an FD team when the cleaner fix is better onboarding, clearer packaging, or a simpler sales motion. A simple boundary test helps. If the business cannot clear enough of the core conditions, it is usually assigned to wait rather than staff up. The three questions are practical. Does the deployment require redesign? Can the deal absorb the cost? And will the work produce something reusable? If the answer is weak on most of them, the function will not pay for itself. That is the safer path in most weak fit situations. Strengthening the product motion gives you more leverage than hiring around a gap that the product should probably close itself. Short sales cycles are a warning because they compress the time available for deployment work. The customer decides before the team can do the deeper design and learning that make FDs valuable. When a deal closes quickly, there is rarely time to map the workflow, place the model in the stack, design the human handoff, and build a measurement loop. Those are the jobs that turn a one-off pilot into a real deployment. These terms sound technical, but the idea is simple. Architecture means how the model is connected to data and tools. Workflow design means who does what, and eval-driven deployment means the team proves the system before it ships instead of hoping it works. If customers buy and move on quickly, the team never gets the time needed to apply those disciplines. In that case, product-led onboarding or a conventional solutions motion is usually enough. Deal size changes the economics. The smaller the contract, the harder it is to justify a specialist engineer sitting close to the customer. An FD is not paid to answer questions alone. The role only makes sense when that person helps the customer reach real usage and also feeds back what the product team should learn. Once the average deal is too small, the hidden costs start to dominate: time, travel, management overhead, and the distraction to product and engineering. Then the function drifts toward custom fixes and heroics instead of scale. That is the right question to ask. If the work looks more like tailored services than reusable engineering, the title has changed, but the business model has not. Patience is a structural constraint. Some boards will fund a learning curve because they expect enterprise deployment to improve over time, while others want proof almost immediately. When the expectation is weekly or monthly payback, the role gets judged by the wrong yardstick. Embedded deployment work usually needs quarters, not days, to show its value. The first benefits are often not visible revenue spikes. They show up as a working deployment, fewer support issues, a repeatable pattern, or a roadmap insight that changes what the company builds next. Reporting line matters because teams are measured differently in different parts of the company. If the function is treated like a sales overlay, it will be pushed to act like one. If it has deployment and learning goals, it can work on the slower curve it needs. A truly self-serve product is the simplest reason not to add an FDE team. If customers can configure the system and get value on their own, the role may duplicate work the product already handles. Self-serve does not mean the product is simple. It means the product has already hidden the complexity well enough that a specialist is no longer required for adoption. In that situation, the better use of money is usually product work. Smoother onboarding, clearer documentation, better telemetry, or removal of the friction that forces human intervention. If the product already does the job, staffing an FD team is just a workaround. The company should fix the product motion instead of building a human layer to cover for it. Governance is the quiet gatekeeper. A deployment can look good in a demo and still be unsafe if the company cannot control, review, and explain what the agent is doing. Reliability means the system behaves predictably enough for production use, and governance means there are guardrails, review steps, escalation paths, and clear accountability. Without both, customer-facing automation becomes risky very quickly. If nobody can see what the agent is doing or step in when it misbehaves, the company is not ready for this role. Hiring FDEs before that foundation exists usually amplifies the danger instead of reducing it. A concrete example makes the boundary easier to see. A company can mistake one successful pilot for proof that it needs a whole FDE organization. A pilot often succeeds because a few people do a lot of careful custom work. That success can be real without proving that the same effort will scale across many customers. If the deals are modest and the buyers move fast, 3 FDs do not create leverage. They create a backlog of requests that the company cannot profitably clear. The better response is usually simpler. Reduce the need for custom embedding by improving the architecture, narrowing the workflow, building lighter evals into the product, and turning the pilot into a repeatable path. Burnout shows up when every customer requires a fresh scramble. If the team cannot reuse deployment patterns, it spends its time rediscovering the same fixes and cleaning up avoidable escalations. That is the boundary to keep in mind. Some problems deserve product work, some deserve process work, and only a smaller set actually justify a new FDE function. The lesson from examples like Ready in 6 is about leverage, not imitation. Embedded deployment work matters when it helps a promising product become a repeatable enterprise outcome. The value comes from bridging the gap between early promise and repeatable adoption. That bridge matters most when the customer cannot get there alone without help. The same example also sets a limit. If the work can be standardized, the function should help turn it into product capability, documentation, or an implementation playbook rather than keep it custom forever. Before hiring, leadership needs a blunt screen. The right questions expose whether the role will create leverage or just formalize custom support. A short checklist can prevent an expensive mistake. It forces the company to name the real reason for the hire instead of relying on enthusiasm from a single pilot. These questions test repetition, economics, learning, patience, and recruiting fit. If the answers are weak, the role is probably premature or poorly framed. That is the clean decision rule. Waiting is better than hiring a team that cannot produce repeatable value. The market will tell candidates what kind of company this really is. The role itself sends a signal about whether the work is strategic engineering or just prettier pre-sale support. Strong candidates read the economics quickly. If the company has short cycles, small deals, and no product learning culture, they will assume the role is mainly escalation work with a better title. When there is real deployment complexity and a path back in a product, the role feels more like strategic scope. That also helps retention because good engineers want work that compounds instead of disappearing into ticket rotation. The interview loop should match that signal. It needs to test architecture thinking, workflow design, evaluation judgment, and the ability to separate reusable product work from custom service requests. The rule is simple enough to use in real decisions. An FDE function only makes sense when it can repeatedly create value rather than appear useful in isolated cases. There needs to be a repeatable loop, deployment patterns, product improvement, or measurable adoption gains. Without one of those loops, the function is more cost than capability. That is the cleanest way to think about it. FDEs work as a multiplier when a motion already has strength, not as a substitute for weak packaging, onboarding, or implementation. The boundary is now clear. Build only where the loop can compound. From there, the practical question becomes how to start well when the answer really is yes. The plan starts with a controlled pilot, because the real question is whether an embedded engineer can create product leverage without turning into a permanent exception handler. A small trial gives you enough signal to judge the role before you scale it. A narrow pilot keeps the experiment honest. One engineer paired with one business owner is enough to see how problems move from the customer into the product, while still avoiding the trap of building a service team that only handles edge cases. The goal is learning speed, not total coverage. If the FDE shortens the path from a customer complaint to an actual product improvement, that tells you the model is creating leverage inside the company. The real question here is what role the forward deployed engineer actually plays. That matters because the pilot only works if the job is understood as an operational role, not a loose label for customer-facing engineering. A forward-deployed engineer sits between the customer and the product team. The work is part technical implementation, part translation of customer needs into product language, and part ownership of getting software into real use without losing sight of production results. Customer embedding is about proximity to the real environment, so the engineer can learn how work actually happens. Consulting is different. It optimizes for custom effort on one account, and that can pull the team away from product learning and toward a services model. A good pilot needs clear edges, or the role starts expanding in the wrong directions. These boundaries keep the work focused on product value, operational ownership, and a clean transfer when the experiment is over. The FD should not become a second account executive, a hidden support queue, or a general-purpose custom development resource. Those jobs blur accountability and make the role drift away from its purpose. The responsibility has to extend beyond the first working prototype. If the engineer only owns the demo, the team learns little about whether the solution can survive real usage. Every pilot needs an explicit handoff plan for knowledge, code, and operating responsibility. Without that transfer, the core team inherits confusion instead of a maintainable system. If the boundaries are unclear at the start, the cost shows up later as missed ownership, duplicated work, and awkward transitions. Strong pilot design prevents those problems before they harden. A pilot needs a timeline that forces real progress, not just activity. The point here is to show how discovery, prototyping, productionization, and handoff fit into a 90-day cycle. The first month is about understanding the customer's workflow well enough to find the smallest useful change. Month 2 hardens that change so it can run in a real environment, and month 3 tests whether the work can actually be adopted and supported after the pilot team steps back. A concrete example makes the shape of the work easier to see. The important part is not the AI assistant itself, but the operational path around it. A demo can look polished and still fail the moment real constraints appear. The FD starts by mapping the decision path, the approvals, the source systems, and the fallback behavior so the prototype matches the real job the organization needs done. That gap is the whole reason the role matters. One version wins attention in a meeting. The other survives the daily work, the edge cases, and the audit trail. The contrast is easiest to see by comparing what the organization looks like before and after an FD gets involved. The changes are practical: better workflow design, better measurement, and faster learning. Before that role shows up, teams often have enthusiasm without structure. They may have feedback, but they do not yet have a clear path from complaints to implementation. That usually means the product idea is being shaped by internal guesses instead of watching how people actually work. When the workflow is invisible, the solution tends to optimize the wrong thing. Pain points can get trapped in the support layer if no one translates them into engineering language. The result is a lot of goodwill and very little system change. Even a convincing prototype can break down when the operating model is unclear. If people do not know who approves, who logs, or what happens on failure, adoption stays brittle. The deeper problem is often feedback delay. If product and implementation teams are not capturing lessons from each deployment, every new rollout starts too close to zero. Once the FD is in the loop, the organization should be able to point to visible changes in how the work is designed and measured. The role starts turning vague intent into operational detail. Now the process can be built around what people actually do, not around a presentation version of the job. That shift is what makes the system usable outside the prototype. A feature being turned on tells you very little. What matters is whether people use it, trust it, and keep it in the flow of work when the pressure is real. The engineer is not just shipping code here. They're collecting what the deployment teaches. Edge cases, integration limits, and failure modes become input for the next system, not just notes from a one-off project. That single partner matters because operations and engineering finally have a translator between them. The business side gets someone who understands the workflow, and the technical side gets someone who can shape the system so it will actually hold up. That is the real value of the role. It does not just improve a model or polish a prototype. It changes the assumptions underneath the process so the work can survive contact with reality. Day 90 is the point where a pilot has to prove more than motion. The real question is whether the work created lasting value, usable adoption, and learning the business can reuse. A pilot can be technically complete and still fail the business. If the process is brittle, the integration is fragile, or people drift back to the old workflow, the deployment never turned into real change. The end of the pilot should be judged on a small set of outcomes, not on activity. These four measures tell you whether the work landed in practice and whether it produced something worth repeating. First, how fast did the customer reach a working version that changed behavior? Then ask whether the intended users actually adopted it in the real process. After that, look for what the team learned about ownership and system design. Finally, check whether the lesson fed back into the product so the next deployment starts smarter. That difference matters at the executive level. A one-off deployment adds cost near the customer, but a repeatable learning loop changes the economics because each pilot improves the next one. That is the leadership test. The right pilot leaves behind a clearer pattern, less friction, and more confidence for the next rollout instead of just a closed project. A pilot succeeds only when it leaves something behind, a team that can carry the work, a pattern that can be reused, and a product lesson that improves the system. If none of that remains, the organization hired a hero instead of building a function. A pilot needs a shape that tests the role before it gets scaled. The point here is to make the experiment concrete enough that both the technical work and the business decision have clear checkpoints. A good pilot has a structure that prevents drift. When the phases are clear, it becomes easier to tell whether the role is learning, building, or actually changing the business. The first phase is about understanding the workflow and agreeing on what success means. The middle phase turns that understanding into something working in a real environment, and the last phase checks whether the change is strong enough to justify scaling. The owner is what keeps the pilot tied to a real operational problem. Without that person, the engineer may fix things quickly, but there is no one with a mandate to remove blockers, make trade-offs, and push the workflow into use. Reporting line shapes what the role becomes. Too far from product, and the work turns into support. Too far from the business, and it becomes an internal engineering exercise with no pressure to deploy. The pilot should make that placement visible through the way the work actually lands. A Ready in 6 example shows how readiness becomes a repeatable deployment motion instead of a scramble of one-off efforts. The important idea is not the name of the program. It is the discipline of turning readiness into a process the company can actually run again. That matters because heroic effort does not scale. A company gets reliable deployment only when the work is defined well enough that different people can carry it forward in the same way. This kind of approach forces the hidden assumptions into the open. Once the team can name the rules, the steps, and the ownership, it becomes much easier to repeat the work without depending on memory or luck. That question defines the entry conditions. Before any rollout can succeed, the team has to agree on the signals that say the customer, the product, and the organization are actually prepared. Standardized steps are the ones you want everyone to follow the same way every time. Those are the parts that reduce variation, shorten training, and make the deployment motion dependable. Not everything should be rigid. Some pieces have to adapt to the customer, the environment, or the specific pilot, and the team needs to know exactly where that flexibility belongs. The handoff is where many pilot programs fall apart. If no one owns the transition, the work stays in experimental mode instead of becoming part of normal operations. That is why embedded engineers are most valuable when they shape the system, not just the immediate request. A first pilot only really counts if it leaves behind a pattern the company can repeat. Otherwise, the team has built a one-off effort instead of a scalable function. The hard part is keeping the first pilot small enough to learn from and serious enough to matter. The choice is not between tiny and ambitious. It is between a pilot that reveals reality and one that creates noise before the team knows what it is optimizing for. One FD is enough to expose whether deployment is actually complicated, and one business owner is enough to keep the work tied to a real operating process. Adding more people too early usually adds coordination cost faster than it adds learning. The pilot works better when each person is rewarded for the outcome the company really wants. That keeps effort pointed at adoption and learning instead of activity for its own sake. For the FD, the goal is not a pile of custom edits. The goal is to leave behind something the company can keep using and lessons that transfer to the next deployment. The business owner should be judged on whether a real workflow gets better. A novelty demo can look polished and still leave the actual process untouched. Leadership needs evidence, not enthusiasm. The point of the pilot is to make a clear decision about the function's future, including the option to stop if the evidence is weak. When incentives are off, people start patching everything by hand, and the project can look busy without becoming repeatable. A healthy FD model reduces dependence on one unusually flexible engineer and replaces heroics with a process that other people can run. A successful pilot tells you whether embedded engineering is changing how work gets done and whether the team is learning enough to justify another round. At day 90, the point is not to judge whether the whole organization is fully built. The useful test is whether the pilot altered day-to-day work and produced concrete learning about the product or the implementation. A yes gives evidence that the model can expand beyond one strong individual. A no does not always mean the engineer failed. It may mean the product, the selling process, or the implementation layer is not ready yet. That is the practical rule. Keep the first experiment small, give it one clear owner, and use the 90 days to learn fast. Scale only when the pilot changes production behavior and leaves behind reusable insight. The timeline makes the pilot feel concrete. Discovery first, then a working prototype, then a hardened solution, and finally a handoff decision. Each checkpoint marks a different kind of evidence. Early on, the team is mapping real pain and workflow. By the middle, it is proving the system can survive real conditions. By the end, the question is whether ownership can transfer cleanly and whether the learning is worth scaling. These questions keep the pilot honest. They force a decision at each stage instead of letting the experiment drift. By day 30, the team should understand how the work actually moves, who touches it, and where the friction lives. If that picture is still fuzzy, the risk is building something elegant for the wrong process. By day 60, a demo is not enough. The prototype has to hold up against real data, real users, and the edge cases that only show up outside a controlled setting. By day 90, ownership matters as much as performance. If the core team can run it and the pilot has changed a few assumptions about the process, the experiment has produced something durable. Once the first pilot works, the harder problem appears: how to hire, support, and retain FDEs while keeping the speed and proximity that made the model useful in the first place.